whoa, that was weird. Always starting a little glitchy apparently, and my camera keeps getting offset. I don't know why. Hello, scuffed start. Are we good? I think my camera is not completely scuffed. Okay, thank you. Hello, everyone. I'm back. So, yeah, sorry about the scuffed start and a little late because I kind of had to go to the toilet, but I'm here now. So, hello, everyone. Just start next stream at like 12:40. Yeah, I was not ready at 12:40. So, yeah, we're gonna continue on the Live2D reverse engineering. If you are coming in new, if you don't know what this is about, go watch the previous stream because the entire like first hour of that was explaining what this is about, or go to the video description and click on the link I have there, an FAQ, because the FAQ explains everything you need to know to make sense of what I'm doing and why I'm doing it. And I swear I'm not evil. So. Yeah, we're gonna skip. Am I stuck? Oh my god, why is my phone? Okay, hold on. Why is my phone? Okay, I get it. The stand is not holding up because it was too loose. Okay, now I think now we're good. Finally, okay. I was like, why is it? I keep pushing it down. No, it was loose. I swear that the rotation's weird. Anyway, good enough. All right, scuffed. So yeah, we're gonna continue with the reverse engineering. I am really excited about today because last stream, which was on Wednesday, was it? I'm lost. Anyway, last stream, we got the entire file loaded into Python into text format. But this stream is going to be all about figuring out what every part is. And so if you don't know, I am reverse engineering the Live2D MOC3 format, which is the format that pretty much every 2D VTuber uses for models, including this one that you're seeing right now. And I am doing a black box, which means I am basically just looking at the file and trying to figure out what it means without decompiling or disassembling or reverse engineering any software. So yeah, it's a big project, but I'm actually really optimistic because it's starting to make sense. So I actually spent a couple hours last night, a bit more than a couple hours, just looking up Live2D videos and tutorials because when I came into this last stream, I actually have never used and never plan to use Live2D Cubism Editor or any Live2D applications for my own legal safety. The reason why what I'm doing is completely legal is that I have not agreed to not do it because I haven't used any software that has a license that says I can't do it. So that means I can't use the software, but I can watch videos about it. And I can read the documentation that's online. You know, there's no click-through license on their website. You can just open a page and read it. So I've been doing that, and I've been taking some notes of how things actually work in Live2D, because that's what we need to make sense of the file. So let me say hi to everyone, and then without further ado, we'll get started. Hello, Jonathan. Hello, Wobo. Hello, Exas. Clary. Hello, Hello. Hello, Yusuf. Hello, Lavrenti. Hello, Dram. Hello, Fish for Teresa. Hello, Furman. Hello. I think that's hello, Alexander Masney. Hello, everyone. I don't have any people today, but I'm curious to see how we go, because I usually get more people on weekends, but the first stream is always more exciting. So yeah, this is going to be a fun stream, I feel. And I feel like it's going to be pretty productive because we're past the looking at crazy hex stage, especially because the way the file is organized. We aren't really going to have to look at weird structures anymore. We pretty much have all the structures worked out. We just need to name the fields. Is Gita? No, we are not doing any software reverse engineering at all, and we never will. That is why it is black box. So let's get started. So I took some notes, I looked through some videos and some tutorials, and what I basically tried to do is document what the things mean. Like what the fields are in the UI, right? So the UI has an inspector tool and it has a bunch of fields. And so these should, in theory, map to some extent to the fields that we have in the file. They might even be in the same order. So I took some notes of art mesh. I think I finally understand what a part is, because I was really confused. Like, why are there parts in art meshes? I think what they call parts are really just folders. It's a folder tree that contains art meshes and deformers. And I think the only thing that tree does is set the default draw order and the compositing hierarchy when you enable the new off-screen drawing feature. I think that's essentially the only thing the tree does. And also, like, you can set, when you enable compositing, you can set like parent blend colors. So it's a very simple feature, and it is separate from the deformer hierarchy, which is a separate tree. So what we actually have are art meshes. No, I think no. Oh, you mean the Ghidra thing? Yeah. Oh, we actually have our art meshes that have these settings. So we expect the name and ID. The name is probably gone. That's probably editor only. The parent would be a part, and then it'll have a deformer assigned to it. You only have a deformer, one deformer for every art mesh. I'm actually learning a lot because I have used a certain different software for 2D animation before, and it works very differently to Live2D. So I am really learning that, sort of what I was expecting is not what is actually going on. If you never plan on using that software and accepting the license review, could have someone who's listening to the software and talking about it. Yes, if they are doing so in a country where that is legal, like France, for example. But I would much rather just not have to rely on that. So, yeah, an art mesh has this. It has a draw order. I saw the 500 in several places, and now I know that is the draw order. Opacity has a blend mode. These are the standard ones, and there's a new thing that has a bunch of blend modes. This is interesting because these are the standard blend modes that you just kind of expect for color, but there's a weird thing about alpha, and I'm actually going to show you what it means, because this is going to be a Live2D tutorial now. I haven't been able to find any explanation for these alpha blend modes, and it took me like half an hour of staring at the documentation to understand what they do. So this is completely besides the point. We probably will not care about this for a long time, but just because I spent so much time looking at this, I'm going to go ahead and explain it, because they have this documentation and they talk about, these are the standard blend modes. These are like, you can look these up. These are standard formulas, and add and multiply are like the, standard game programming add and multiply in pre-multiply colors. That's all cool. Alpha band over and alpha band at top are completely standard, the same as SVG. You can look at the I looked up the W3C SVG specification, which has formulas for these. And so over and the top are standard, and out is standard. And then they have this conjoint and disjoint thing. And I was extremely confused about what is going on here, because this explanation is terrible. This explanation is absolutely terrible, because this image they have here is not actually show. It's not useful to understand what this blend mode does. You would never do this with this blend mode. This is not how you use this blend mode. This is a terrible explanation. Like, the person that developed this and the person that documented this did not understand each other, because this makes no sense. And it took me forever. I'm like, why is it, like, if one is higher opacity, the bottom one doesn't show through, otherwise it shows through? Like, this makes no sense. And then disjoint also makes no sense. And then there was this one thing at the end where it says, when line and fill objects are separated and gaps are visible between them, disjoint can be used to make it look as if the gaps are filled, which is a terrible explanation, but it finally made the light bulb go off in my head and understand what they're doing. And so I wrote the formulas that I'm pretty sure are what they're actually using. I guess these, but this makes sense. So I'm gonna visually explain to you what those blend modes are, because they make perfect sense. They just explain terribly. And for that, I need a vector editor, because what those blend modes are is they are blend modes designed to overlap and abut anti-alias shapes, which is why you never see those blend modes in game programming, because game programming does not use like shader-based anti-alias vectors pretty much ever. What you do is you have either multi-sample anti-aliasing or something like that, or you have just post-processing anti-aliasing and filtering. You almost never do vector graphics with anti-aliased edges in games. And this went to the other folder. However, when you're doing 2D, and also you won't see them in a graphics editor because you almost never do this when drawing either, because it doesn't really make a lot of sense. You don't copy and paste. You just kind of fix the problem in a different way when you're doing graphics. However, if you're doing animation or things with vectors, it actually makes sense that you might want to do this. And so what this is actually doing is, okay, the problem it is solving is, if I draw a shape, now this might not actually happen, but where's my thing? If I draw a square here, a black square, and then I copy and paste it, and this is probably gonna be fine because of the way Inkscape works. If I put another one on top, and I make this red, or even if I make it white, and let's turn off the grid. Now you see that black edge there. I don't know if you can tell. There's a black edge there, right? See that black edge, that gray edge? I don't know if you can tell. That gray edge is what this blend mode is solving. In this case here, I would set, Inkscape doesn't have that. I would set the blend mode in Live2D to conjoint, and it would resolve this black edge magically by blending those pixels in the correct way so that that does not happen. The other blend mode is for this. When I have two squares next to each other and there's a white edge in the middle, if I set the blend mode to disjoint, it will fix that gray edge. That's what those blend modes do. And so the only way to understand them is in terms of coverage. What those blend modes do is, let's say these are pixels. Let's say these squares here are pixels. Okay, actually let's do it smaller so it makes more sense. Let's say these squares here are pixels, the small grid units, right? And so I have, let's say, a bar that is coming in. Let me make this a little bigger. I have a bar coming in that is, I don't know, with some color. And I have another bar that is coming in from this side. Now, remember, these are pixels, right? So these are right now aligned on the pixel edges. Now, what happens? Let's make a nicer color. What happens when they overlap? Now, these are whole pixels, so this is going to be anti-aliased. What this blend mode is doing is, say this red square, we're going to make sure this one's on top of the green one. Say this red square is around half of the pixel. When you are in disjoint blend mode, what it is doing is, the green opacity is filling in the transparent portion of the pixel, let's turn off snap, until it reaches exactly what is the fraction of the pixel that is transparent. When it starts to be more than the fraction of the pixel that is transparent, it takes over the red one. Okay? This is what disjoint is doing. Okay? So disjoint is basically filling in the background linearly. It's not multiplicative. Alpha is normally multiplicative. This is not multiplicative. This is additive. This is basically additive alpha, where it is taking a max and saying, okay, the green is filling in the background, and this point is equivalent to as if you do normal blending and the green is covering the whole pixel. But it's not. And then once it starts overlapping the red, it takes over. And so that's how this computes the correct pixel color when two shapes are touching each other. Now for conjoint, that's the opposite case, where you have something coming in from the top, which means that as the green starts coming into this pixel anti-aliased, it takes over the fraction of a pixel covered by the red line, the red box, until it reaches all of it. And at that point, there is no red anymore. Now the green is completely replacing what is under it. That is what those two blend modes are doing, and it makes perfect sense when you explain it like this. And the explanation on the Live2D website is terrible and does not. And so, if you want to achieve that, which I'm pretty sure is what they mean after I finally figured this out, these are the formulas you would use. All right, there's that. So that is one high-level Live2D mystery uncovered. I don't know if anyone documented this before, but oh gosh, that was really frustrating to not understand until it clicked. And it makes perfect sense. It's like, of course you would do this. If you have lines and artwork and they exactly line up with each other and they're cut in that way, you use this to fix the gaps. And if you have two things overlapping each other to like change a color or something like that, you use the other one to like color a part in a way like if you, for example, if you wanna put an overlay on a part and you wanna do it in a way that is not just a mask, and you don't want to just use a top, then you would use this. Like there's anyway. So there, that's that. Hope that explanation makes sense. So those are those blend modes. Anyway, that's art meshes. Then we have coding is just the like, you know, whether if you know graphics programming, that's the draw rear, draw backside, yes, no flag. Like single-sided or double-sided polygons. User data is a separate JSON file, and this is actually just the vertex editors that's useless. Parts are, as far as I can tell, are just folders. So they have a grouped thing which seems to merge all the draw orders. That's a flag. Guide image is probably an editor-only thing. And then off-screen drawing, I think the version of the file I have probably doesn't have that flag. And then it has all the art mesh blend settings, but those are for the latest version. Then for parameters, we have a name ID. The part, I actually don't know if that, I guess the parameters can also be parented to a part, which makes some sense. Has a range. Blend shape is interesting, because I also did not know how parameters work in Live2D. Now I do. So it has this value adjustment remap feature, but I think this might just be destructive and not something that's in the file. And then they call the actual data assigned to the points on the parameter keyforms. Now, one thing I did not know about Live2D, and this is kind of insane, is that by default and originally, parameters can only mean can be either mapped or not to a certain, art mesh, and they are multiplicative. I did not know this. If you assign 5 parameters to an art mesh, you have to rig number of points to the power of 5, which is insane. Like, even if they just have 2 points and you rig 5 parameters into an art mesh, you have to rig 32 points, which is crazy. And it makes sense if you need full control, but it makes absolutely no sense for the vast majority of things to use parameters for. And so I'm actually kind of having my mind blown by how strangely Live2D works now. So actually, the 2D grid thing is just a visual thing. The grid always exists. They have this multiplicative grid, multi-dimensional thing going on with parameters. And then the linking thing is just a visual aid to link them into a grid you can edit for 2D pairs. They have interpolation. I think that is actually, from what I understand, that is baked. So they just have a special interpolation algorithm that, just subdivides the parameters and generates all the data, and that should be baked in the MOC3 file. So don't expect to see that. And then the way the default parameters work is this weird explosion thing. So there has to be some way in the MOC3 that these, multi-dimensional sets of inputs are mapped out into art meshes, and we'll have to figure out what exactly the shape of that data structure is. Then the other thing is, after that they realized this was insane, and so they added a thing called blend shape parameters. And so blend shape parameters are actually what I would expect would have like existed first, which is that they're just independent and then just additively added like a blend shape in a 3D program, which makes sense. I always assumed this is how parameters would work. Apparently not. So yeah, blend shape parameters are just, you rig one parameter, you rig another parameter, and their effects just add up. However, they also have, and this also makes sense, they essentially have a list of limits. And so when you have a blend shape parameter, you can have blend shapes that don't combine well with each other. And so the way they fix that is that a blend shape parameter can have a list of other parameters that sort of clamp those parameters. And so what you get is a curve mapping from the range of the original parameter to 0 to 1. And what that does is it essentially limits the effect of the current parameter when the other parameter is at that value. So you can have it so that when one parameter is at 100%, it invalidates a different parameter. It reduces its effect to 0. And that is how you avoid having parameters that clash with each other. And so you can control the curve so that, for example, when one is 100% and the other one is 50%, they still add up properly. But as you approach 100% on the other one, the first one gets canceled out. And so that works out. And so that is essentially a list of curves mapped to a parameter and other parameters. So we expect, I think I saw something like that in the file. So we expect that. Then we have deformers. Those have a part. Those are linked in a tree. So deformers are, I also didn't know this, you only assign one deformer ever to a art mesh, and then the others are always parents. So for warp deformers, you can have opacity and other stuff that I guess is just another control for the multiply color. I honestly don't know why there are so many controls for these things. I guess it's just because you might want to, it's the only way to combine them, I guess. No, it's not. You also have parts. I don't know. Live2D is strange. Then they have these conversion divisions, which I think is the actual grid that is used for the warp. And my understanding, I'm not 100% sure on this, but my understanding is that what really happens is just that the warp parameter just has a grid that is really just like a quad grid. And I think it probably has to be evenly spaced. I hope, I assume, because this would be computationally sane, that the original grid of the warp always has to be a uniform 2D grid. So there should be at some point, essentially an affine transform, or a set of coordinates that define a warp deformer's resting pose, so to speak. And then what you do is you deform those points, and they do a standard, deformation on the grid. And so my understanding is that what happens is that any vertices that lie within that grid get deformed, by interpolating uniform between the four corners of the grid square they lie on. There's some Bezier stuff, but I think that's only editor only. I think that's just baked. And there's a Boolean for legacy behavior because they seem to have started doing some kind of perspective correction thing, like the previous interpolation algorithm was weird. So I guess the way they interpolate the, within a parameter is actually using my guess is they're doing a perspective transform. So they treat the quad grid square you're in as a 3D plane, and they do a perspective correct interpolation within it instead of a naive linear one. You bought a Mac? I've always had a Mac. So then for rotation deformers, they're actually also translation deformers. That is both warp and rotation can be used for translation. So rotation, it's more like rotation translation deformer. They have an implied X, Y, and base scale. It's also a scaling deformer. So it's rotation and scaling and translation and translation deformer. I don't know why Live2D always picks the worst names for everything. So rotation and translation. Yeah, let's get Plasma on a Mac originally. So rotation and translation and scaling. So it's really an affine. I would call this a 2D affine deformer, if you ask me. What that does is it has an XY base scale and an angle. Freeze angle is basically setting the offset or neutral angle, has a scale, and then opacity, then again, the color thing for some reason. We don't care about vertices. So the interesting thing is that when you put a warp on top of a rotation, when you put anything on top of anything, as far as I can tell, a deformer is really just deforming another deformer, which then deforms the final mesh. So I actually saw some people, I think, sort of say that when you chain deformers, you get like multiplicative computational cost. As far as I can tell, that's not true. As far as I can tell, each deformer just deforms the child deformers, and then those deformers just, once deformed, then deform the mesh they are applied to. So that implies that you need to have enough divisions in the child deformer to keep the accuracy of whatever's in the parent. Like, it doesn't make sense to have more divisions in a parent than in a child, because it wouldn't work. I think. That is my understanding. So yeah, those have rotation. The strange thing is that when you have a warp on top of a rotation, it only affects the position and angle of the rotation deformer. As far as I can tell, the position is just moving the root, the origin of the rotation deformer, but I have not figured out how the angle works. Just looking at videos, there's a rather confusing, mapping between angle and how the parent warp deformer works. That will probably have to be something that we analyze experimentally on using like VTube Studio to see exactly like if we can figure out what the math for that is. So yeah, that's kind of what I wrote here. And they also said that if you put points out, if your mesh deformer does not completely cover the children, the deformation is extrapolated outwards. I don't know with what algorithm, but there's an interesting thing where they mentioned the computational cost of doing that is supposedly 4 plus 2n for n points outside the deformer. So they have some kind of like base cost for any points outside of 4, and then each point is twice the cost. I don't know how accurate that number is, but it's interesting that they threw it in there, and it might give a hint as to what algorithm they're using for extrapolation. Because the way I would assume this is implemented is that if you have a point inside a, you're mapping child points from their original position into the coordinate system of the mesh, right? So basically you take a point inside the mesh, you transform it to the coordinate system of the mesh, and so you get an XY, say from 0 to 1, and that tells you what division you're in, and then you just interpolate based on the 4 corners. So it's all very simple, fixed cost, right? It's just an affine transform, and then floor and look up 4 corners, and then do the math for the perspective interpolation. If it's outside, if you end up with out of range values, then I don't know. If there is twice the cost, that kind of implies that you're using 8 points as the interpolation source, and then I don't know where the 4 is coming from. Or maybe what they do is they take the 4 corners of the mesh and do something to them. It's kind of interesting. Because the 4 there kind of sounds like they're doing something for the 4 corners of the deformer, and then interpolating based off that. One way to test that, the test case for this would be something like having a grid deformer and having a point outside, and then moving the grid points inside the corners and seeing if the outside points change at all. If they don't, then we know we're only using the corners as the interpolation sources. But then again, if they do it that way, that means that any point that is just outside the deformer on the edge would not deform evenly with what's inside because of not using the grid dimensions. I don't know. It's strange. Okay, I don't know. We're gonna have to create some like test case MOC3 files at some point and visually play this back in VTube Studio and see what it is actually doing. So it's gonna be very interesting actually generating these files. We'll have to make some textures and in Python generate some info. So that's fun. Skinning is also another interesting thing. So this finally, it makes sense how glue works when I saw what skinning is. That is just an editor feature, but what it does is this is how you do hair. I actually just, I assumed that hair would be done by just deforming different parts of a mesh in different ways. Well, apparently you can't do that because you can only have one deformer per art mesh. So what they do is they actually split them. They have a feature that just cuts up an art mesh into multiple. And then they put rotation deformers on it, so that's how the hair kind of rotates. And the strange thing is that, so they have this glue, which is how you keep the parts from, you know, just cracking at the joints. And so the glue is overlap is only between two. It can be the idea with the glue is actually that the two art meshes need to have a set of vertices that are the same, that fully overlap, and then the glue has a weight that is applied to every vertex that tells you which of the two textures sort of wins. And so that's how they make sense of that. So and we already saw that structure in the MOC3 file. So this explains that. And the one interesting thing that I didn't see documented is that when you skin things, actually I can show you because they have this in the docs. Where is skinning? Where is skinning? It's possibly here? No. Rotation? No. Auto generation? No. Where is skinning? Where is this? What? Have you read the textbook on algorithm production? So I'm not very good at algorithms, actually. Okay, where is skinning? That's analysis. The former palette? No. This is what I mentioned about the interpolation. Like, they had something weird going on with the interpolation before, which is very strange, actually. And my guess is just that they used to do linear, and then they switched to like a perspective correcting. Here, it's under key form. Okay. So what they do is that you basically put a chain of rotation deformers, and then they do this thing where it automatically splits the art mesh into parts, and it basically glues the overlap with the other one. And I was thinking, well, there's one problem with this. If you have art meshes that overlap each other, they would render on top of each other, and that's a bad idea. So they have to cut the art meshes, and you can see that here inside the glue, which means they need to have an art mesh like this that has extra vertices, because these extra vertices outside are used to deform them and then glue them to the other art mesh next to it. But those extra vertices aren't actually drawn. These polygons are not drawn, and I did not see an explanation of that anywhere. Now, of course, in the file, you should be able to do this very easily by just having these vertices and then not having triangles declared for them. But I was not able to find any editor feature that described how you could have like sets of vertices connected in an art mesh that aren't actually creating polygons. Maybe that's what's going on is you just leave the edges out, but then this drawing is incorrect. And that's not what I saw actually in a video I saw of people using this feature live. So this is a mystery in how the tool internally works, but it does mean that what I expect to see in the file is that these triangles are missing. The vertices are there for the glue to work, but the triangles are not actually declared. So there will be sort of orphan vertices in some art meshes that are not linked into polygons, and those would be used for this feature. But it's very strange that this is not explained anywhere, and it's not explained how you could do this manually. It only seems to be implied by the skinning feature. So another strange mystery, Live2D. Anyway, that's what that does. And then the glue thing I already mentioned. So it does seem to map one-to-one. So this is starting to explain a bunch of things. Another interesting page that I want to look at that is going to be useful is this one, select target version, because we saw the file seems to have extensions that kind of were added in order. And that is probably going to give us a hint because this is the order the features were added in. And so those extensions to the file should probably be in the same order as these features were added. And that'll give us some hints as to what they are. So without further ado, let's take a look at some of these things and see if they make sense. So I'm going to rename some of these things. For example, part here. Now, what I really want to find out is what all these like substructures are, right? We know there are, for example, I forgot to mention you can have multiple clipping masks for a art mesh. So this file format is a struct of arrays. It is basically, you can think of it like a normalized SQL database, which means there has to be like each one of these is like a table, right? This is like a SQL database, and each one of these is like a table. And so each of these tables is how you link, array. It's how you do arrays, basically. So that's why you have so many things that we don't know about, right? We have these parts, deformers, art meshes, params, but then we have things that don't make sense. And so those would be the normalized tables that hold arrays and things like that. Could be the vertices that are in the equation to not final. No, because they are needed for the glue. Those vertices are still needed in the final file because a deformer has to deform them, and then another deformer has to deform those vertices in the other texture, and then they need to have a glue applied to them. So those vertices are literally there only for the glue, but the glue is part of the file and is calculated at runtime, and so those vertices do actually have to exist. They just are not drawn. So yeah, let's see if we can make sense of these. So I believe, because we saw this file, the version number on the file was a 5, I believe, and I would not be surprised if that is 5.0, which probably means there's this like major and minor version here that we don't know about. So I believe this was probably created with 5.0, and that means that we are not going to have off-screen drawing or blend modes. Which makes sense because we have we have off-screen drawing, which is a feature in parts, and our part structure is actually very, very simple. So that definitely doesn't have the off-screen drawing. However, this unknown float, pretty sure that's the draw order. So let's look at that. Python MOC3 py. Oh, a surgeon? What? Slit lines? Oh, that's something I edited and I think I messed up later. Oh, sorry, indent. Wait, hold on. What? Built-in function methods. Oh, I'm not in the. Wait, what? No, that doesn't make any sense. Oh, is it because I? Huh? 9. Oh, I messed up. Format value. Why would that return a? Huh? I did something dumb. R strip. Oh. Yeah. Okay. That would do that. I'm silly. Okay. Okay, so let's look at the parts. Yeah, so we know that unknown float is the draw order, so that is an easy one. They call it the draw order. I guess call it Z. You know, we can start using better names than Live2D names for things. I'm just gonna call it Z-pos because draw order is kind of terrible because it's not an order, it's actually a weight that then sorts by position. So it's really Z-pos. Parent index, I'm gonna start using, I'm gonna try to make a convention for naming these references. I'm gonna call this I-part parent. I'm gonna try to use this I convention for references, because I might be able to programmatically declare them later. Depth, yeah, depth. Let's call it depth. Depth makes sense. So we have depth, and then actually let me pull this parts.txt into a separate window. Not parts.txt, sorry. Notes. So we have parts. Actually, I can use a split view. Probably a little easier. Let me just make this bigger and use a split view. Can I just columns to? I think I can do that. I'm not even in the right folder here. Ah, there you go. That did the right thing. Okay. So we have part. Where's part? Part. Okay, name. This header is a little sus. Like, a lot of things have that header. I wonder if it could be related to the name. Like, it's possible this structure is used internally in the editor, and then they like don't export some parts, and they just kind of stuck. Because this could be like a you know, an internal reference to strings or something. But I don't know. Either way, the ones that they call ID are actually the name. So I'm gonna call this ID to be consistent. Then they have unknown 0. That could be the grouped Boolean, but they have 3 flags here too at the same time. So, that is interesting that there's 3 flags, because we don't really have 3 flags here unless it's guide image. One thing that is going to be important is to look at whether those parts are ever... Okay, so those 3 flags are 1 here. And we can just look through all the parts, and those flags are always 1 in our case. Yeah, they're always 1. So at least we don't have information on those for now. Now, I don't expect all the parts to be grouped. That would not make a lot of sense. And I wouldn't be surprised if none of them are grouped, because they're not grouped by default. So I'm going to go ahead and assume that this is grouped. Now there's that index unknown. That seems to just be exactly the same as the part index. So I don't know why they would have that duplicated like that. Maybe it's something, maybe it's just an artifact of like how they edit, and like maybe they can be used to resort the parts. So we'll see if that ever changes. So one thing we can do for this is we can start adding validators. And so that way, when we run this on files, we can like print whether things are correct or not. Now, one thing I need to do for this particular validation is to have, let's go back here at the bottom. I hope Sublime is, yeah. I need to have the index available to a part itself. So I guess when we create these objects, which we do here, all of these are gonna have an index originally, I guess. So, well, we can just set it at the field level when we load them here. I can just create it here. Okay. Let's just add it. So if it is a class, those are always going to be indexed. Might as well do it like that. So we differentiate it from a field. And what I really want is an assertion here, like a smart assertion. That's the best way to do this. This is the kind of thing that would be much nicer in Rust with macros. Actually, maybe Python asserts work for this, because if I do Python, you get an assertion error. But you don't get the values though, so it's not useful. I guess I can just use assert, and when an assertion fails, just print the whole part, and it will tell us what is wrong. Yeah, you can catch the error, so and so what we can do actually, I kind of want to have two things, but no, it makes sense like this. Basically, anything we don't know about, we assert. And so then if we ever discover something that is different to the expected values, we validate that that exists. And then the caller that's going to validate these is just going to check everything. So the way we do that is, I would like to put MOC3 in here if I can. Can I do that? Yes. I can have a validate here. So basically just doing for every object, field class. Something like that. And so if anything fails validation, we print that. So I need to have a default validate that does nothing. It's interesting that they added this depth at some point. So that kind of is that mentioned anywhere? Blend shape, multiply color screen, blend shape, motion sync, blend mode. No, that's not really mentioned anywhere. It might be they just added it for some reason. Or maybe it's the, not the palette, the inspector. They have that draw order. And the group. And they don't explain anything. Yeah, so they don't say when they added that. Maybe it was just added really, really soon. Either way, okay, so we have the part. And we don't know what those are. We assume this is grouped. And there's not much else that goes into a part. Because it's really just a folder. Now, the former... Let's look at the formers. Actually, we can do assert self-done grouped. Make sure this is actually a boolean. I could do that by declaring types like a bool something, and then at parse time it would do that. But for now, I'm gonna do it like this just in case. The former. So yeah, the header, the name. This is actually ID. And then we have a link to unknown 5. I part maybe makes sense, and then we have a parent, so that makes sense. So I part that makes sense because the former can be inside a part. And I think that should be signed. Let's look at how this prints. I mean, it's likely that all the formers in this file are inside parts. Because that would be, you know... Yeah, but I think it makes sense that they don't have to be, so this probably is assigned. And then it would have a parent. So this would actually be the former parent. And now we get to some interesting stuff. So what is this unknown 5? This is an index into another structure. And there's another structure. So for the former, first of all, we have the flag, the type of the former, and that is pretty obvious which one it is because I looked at it earlier. Warp, rotation. So flag 3 there, right there, is obviously the former type. So this is type. And it's a type. I actually probably want to use the proper type for this. So constructs enum. I know that is a thing I can do. Yeah, I do enum, so I can just do it like this. And we can just say which one was which. 0 is warp. That should take care of that. I probably actually, you know what? I'm gonna say integer convertible string or an integer otherwise. You know what? I'm gonna make an enum for bools. Because we use that a lot. Actually, this is not the best way of doing that. What I really want, because they have this flag thing, but it's a single byte. So what I actually want to do is I could just have this and then like padding, I guess. But actually, yeah, no, that would work. Hello. Okay. Yeah, I guess we can just use flag and just pad it, and that'll be basically a. I'm in padding for but it's padded. Yes, that's funny. Ow. Nani. I got.
Well, are you gonna be hungry?
I'm getting hungry actually.
Pizza bread?
Be nice.
Just pizza bread?
Yeah. Yeah, I think we can probably just use a padded flag. So padded flag, 4 flag. Bull 32. Start using that. Actually, just call it flag 32. Nah, call it bull. I like bull better than flag. I don't know if this is gonna work with the in, but let's find out. Let's run validate on everything after the file. Yeah, that still validates. Okay. I'm not flag would enforce that itself. I really would like to check it itself actually. Flag. Yeah, it only does one. I would want to validate that sort of universally. So, well, I can just, I can just kind of cheat here. I can do super.validate, and then just have the constructor do this flag magic by itself. So, super validator here, I can just, instead of failing at parse time, I can just check the fields, and then if it's an instance of, oh, this is ugly. If it's an instance, nah, let's do it at parse time. Changing my mind. Yeah, for bools, it's fine if we fail at parse time. We'll be able to debug that pretty easy. So let's say that adapter there. How do I do that? Because enum also isn't validating anything. Validating and filtering. How do I do, if I do a validator for flag, that already loses the value. So I need to do this a different way. I need an adapter, I guess. Yeah, let's do this the hard way. Yeah, that's a little safer. And then the enum thing, Yeah, there's no default. But you can use the mapping. That makes kind of sense. But then that's actually worse. Okay, let's see if we can do a quick hack here for the enum thing. So if I do import construct enum from construct import star. If I do enum inside to ul comma a equals 0, b equals 1 dot parse. Actually, I can just do it like this. So yeah, so you get A, you get B, and then you get enum integer string. So basically, I just want to validate that there's an enum integer string. There's enum integer and enum integer string. Cool. So yeah, I just need to validate that it is an instance of construct core enum integer string. How do I validate? Or I can just use the subclass of enum probably. Where's the source code? So enum is an adapter, and it takes that init. And I actually can literally just override that. Okay, cool. Class checked enum, and I can just do that then. And that will do what I want. Checked enum. So now that we have those both 32s, we don't need this anymore. We are actually already validating that. So then we don't need grouped because that is already checked. We can just check the self index and that the part parent exists. So now we can do the deformer also. So we can say assert self dot, well, these are flags. So let's make these both 32. So I deformer parent, deformers, we check that that exists. I part, we check that that exists. And then what do we have for flags? So we have the type, that is already checked. Deformer. Wait, what happened there? STR didn't work? Validation failed. Oh, yeah, hold on, what? And the object, not the exception. Hmm? Okay, so we have a part from our parents, type board. See, type board rotation. That looks good. And these flags are also always true in our case. So we don't have an index on this one. We assert that we have flag 1 and flag 2. See, now it validates. Okay, so we don't know what those flags are, but they're there. Oh, one thing we do have at some point, but those weren't added, so it's interesting. There is the compatibility thing. Is that set by Spectre? Warp Deformer. Yeah, it has the compatibility setting. Deformer conversion, Bezier conversion. So those might be legacy settings, but it's interesting that they are in the middle there and not actually added. So I'm not sure if those are really the compat settings. They could be the compat settings though. I'm not sure if this file was really extended in order like that. And that would mean these checkboxes are backwards. So then we can check that we have these other references. So we have IUNC5. That is always set. And we validate that exists. IUNC2, UNC802. I hope we can make sense of what those are later. Yeah, so UNC5? What? Mock UNC5? Did we rename those? Is that the key point arrays? That would make sense for a deformer. So IP key point arrays? It validates. So that would make sense, linking deformers to key points. And that would make sense because each deformer can be connected to multiple parameters. But there has to be a weird combinatorial explosion there, so we'll see how that is set up. Anyway, this makes sense. And then the interesting thing is that we have no details about the position or anything like that about the deformers. And warp and rotation are supposed to have different parameters. So maybe UNC802 is like the extension for that, possibly. Because, yeah, see, we have a vertex offset account on the length. Oh, and 36 sounds like 5 by 5. Yeah, so 5 by 5 divisions is 36. That makes sense. So this is not UNC type. This is actually the number of divisions. So UNC802 is actually the deformer info. And this is for mesh deformers. And is it also for rotations? So that makes sense that they do it like that because they can have multiple types. So in warp and then rotation types. I get it. Okay, so I think what's going on is that A02 is the warp deformer info. And A03 is the rotation deformer info. Yeah, because those look like they're likely angles. The -0 is sus, but it's probably the base angle, and that's just like a rounding error. And then they have this offset and count, which is probably the parameters. Or something like that. So actually, this is it's a different I. It's a info index type params, actually. I type params. And in this case, that would not be let's call it mesh params. Not params. Params is overloaded. I type fields, because param is a very overloaded word. I type fields. Fields? I type info? I type info. mesh info, rot info. And so then this validation depends on the type. If self the type equals, and then we don't actually have a warp. Yeah, that's a good question. How do we get those enums out? Can we like do comparisons on those enums? See examples. Supports an enum module. Ah, you can give it a separate class for the enum. Okay, that makes sense. So I think we can just declare these as nested classes. This is an interesting Python field. You don't normally do this in Python, but I don't see why you couldn't do it. So we can just do enum actually. This should never happen, but I'm just being paranoid there. So mesh infos and rot infos, that makes perfect sense. So now we can go here and say mesh info and rot info. And we just have to declare those in the arrays here. Arrays, mesh infos, rot infos, plural. And the counts here would be mesh infos, rot infos. Data, yeah, data would kind of make sense actually. We call it mesh data. But data is a little, I guess, yeah, rot data. We can do that. Mesh data, rot data. I'm deliberately keeping this plural thing in here because I might want to do programmatic checks on the names again, so let's keep that. Mesh data, rot data. Yeah. And there's more here. Okay, cool. And validation failed? Wait, failed nothing? What? Huh? What do you mean no exception? What? Assertion error, okay. So this is not working? It says rotation. This seems like a bug. Yeah, that's definitely a bug. Why is it returning? Yeah, that is a bug in construct. It should be using the actual enum you pass as that. Are enum and merge or enum to merge mapping? Oh. So it merges multiple enums, okay. But it does actually return values of that enum. Yeah, we're gonna have to fix that. Now it works. The only problem is that now it does not print as a string. Can I make it print as a string? So enum value, enum type. Huh? Arigato! Oh, pizza bread.
I'll take a photo, it's so cute.
It's so cute.
But I forgot you used pencil again.
I need a spoon at least.
Is this
So
my
cute. Huh?
Is this my phone?
Yeah.
Papa.
I guess I should eat something. So what I really want is an enum that you can do verify. I didn't even know that was. Yeah, that makes sense. So I want something that prints as integers. Yeah, so I want SDR to use the name.
Oh man, we don't have spoons.
It's okay. Hmm.
Chuchui.
Hmm.
I made you handmade lemonade.
Oh, arigato. Looks so good.
Right.
Why are you so nice to me?
It's the mean I grew.
So good.
Yeah.
Arigato. Ah. Okay, so possibly I can just do does that work? No. Oh wait, this is supposed to be int enum. That does not work. Oh wait, no. Hold on, I'm confused. This is the construct enum, and then int enum is the okay. Yeah, well, I can just override it like that. Or just my int enum. Now you get type.rotation: 1, which I guess is not bad. Sorry. Next recursion. Yeah, okay, that doesn't work. Actually, not sure how to do that. SDR. Do the values have a type I can check, like the name? I think they do. Yeah, name of the map. Yeah. I think I can just say name. Does that work? Yes, that works. Okay, so that gives me the rot. And then I can actually do a little better formatting here, because I do like the number, but I think yeah, this is good. And then the check works. Okay, cool. Patching. All right. So now this all validates, and now we have rot infos is missing. Why is rot infos or rot datas? Because I called it datas. Okay, now it validates, and we can get rid of all these prints. Spread the Cyan Nyan, it's so good. Okay, I think that makes sense. So now let's do a pretty print because we already have the child thing, so we can actually print it with a similar logic as this. We can say deformer type info and I can just print it like this. And now it prints the type info. So now this vertex offset count on length. Now we're talking about something, because now this is clearly related to the number of divisions, right? So let's print that. We have mesh data, and this is not type. This is actually x divs and y divs. And so then this is actually the vertex count, indeed the vertex count of the deformer. And so now the interesting thing is this is not really the vertex. Like, I don't think this is actually specified anywhere because this is really just the number of vertices, which should be always x plus y, like plus 1 multiplied by each other. So we can validate that here again. Let's say invalidate in mesh data. Self.assert vertex count equals divs plus 1 times self.y divs plus 1. That should always be true. Yeah, and so that validates. And so now this offset thing, I don't know what that is, but what is the relationship between that and the like why is it 1? Why is this 3? Does it have to do with the key points? It might have to do with the key points. So what about this key point array? Let's print the key point array because those can have That's in the deformer IPE key point array. And for some reason, there's just a single pointer, which is really strange. I don't know why there is a indirection here with this single value. So let's do the, let's print these. IP key point array. So now we have the pointers. So these all seem to have a single deformer attached. As like a single parameter, I'm guessing is what those key point arrays are. Because you can have double ones. But these are all single ones, it looks like. Unless I missed something. Interestingly, none of them have more than one mapped, which seems unlikely. So I probably missed a count somewhere. It is possible that has something to do with this. There's an IONC 5 that could be related to the to the axle mappings. So then what's going on with these vertices? Offset 0, 1, that does not make sense. And then you get 10. So this is really a count. 0, 1, and then 1, 9. So this is mapping to some vertex count. But why do we have only 1 for this one and then 9 for this one? That does not make sense. If we have 5 divisions and then 10, how can we only have 1 vertex and then 9? That does not make sense. So something is different here. That could be a key point array mapping instead. That would mean this one has 9 parameters mapped to it, which is kind of crazy. This IP key point array might be wrong. Because one thing we need for sure is essentially an affine mapping that tells us where this deform is and what its size is. And IONC 5 might be that, or it might be related to the key points. Let's see what ONC 5 is. So ONC 5... which isn't even ONC 5. That's... isn't that a list of key point arrays? See, I already renamed some of these things. Oh, that's P key point arrays again. Ah, hold on. I think that was P key point arrays. It should be. So then we have that again in the data, which means one of these might be wrong. So let's print that one for the subdata too. Okay, that validates. Okay, so now we have the same key point array. So there's a duplication there. And for rotation also. Okay, those are the same actually. They always seem to be the same. Let's validate that they're the same. Actually, you know what? Let's do a do a self.type info property here. And we can just simplify it to this. And we can just delete that. And the type should already be set, so we can just put this one in here. So we can validate that is the same as the parent. And do the same for raw data. Self I-type info. Validates, and so we have the former. So we have the key point array that is duplicated, and I'm starting to doubt if this is correct because it might be a pointer to the wrong thing. I suspect those have to do with the key points, and then they might be mapping into some kind of data array for all the data. So that offset and count are probably the same. Yeah, see, 18 and 21 just adds up, but 18 is the same as this key point array offset. So what we're gonna do, I like using grep for this. And I want to get rid of some of those prints. This is all old stuff. Just comment it out. Yeah, so now we can see the, you know, the value set. I'm gonna add a little feature here. I'm gonna add a something to enumerate all the values of a field.
I got you the spoon.
Thank you. Arigato.
Have it there.
Yeah, with the bread, so like I'm so full with that. So this would be field and not even field. It'd be this is called object and field. So we can just say object in that vals dot add get enter object field. And so we can do a print here. We can add a print moc3 dot values and we want something like actually let's do because we want the actually, you know, I want a to be able to do nested fields here. So let's do I in field split dot I. We get the final object, and then vals add object. And so what I can do here is enum values deformers, and then have like a path here, which is type info dot key point IP key point array, something like that. Yeah, there you go. Okay, cool. So now we know exactly the range that those are pointing at. And this is going to be useful because if it is a range of values, it should line up with those. And so now I can do less and look for the deformers and just give me a little new window here I can put on the side. Hello. So now 0 jumps to 6. I hide the sidebar here. So 30 is a 1, but 0 is 6. So that's kind of interesting. And then that jumps to 10. 1 is 9. Actually, you know what? I'm gonna make it take 2 pulls so we can have more than one thing. So if it's a single one, we do it single values. Otherwise, we do tuples, which means it should still work the same. No. Sorry. Yes, now we have that. And then we want to say fields here. Say fs. Lens fields 1. Yeah, so now we have that. And now I can make sense of that part here by going to the... So let's look at what deformer. So we have mesh data. Let's just say off and count. We don't know what these are, but it's probably the same as the rod data. They might not be, though. Does this work? Can I have, like, keyboard only args? I don't know if that's a Python thing. Yeah, it works, okay. Enum values, deformers, I keep on the array, and so I can add a filter to this. So I can make it a little smaller because otherwise I can't fit. So I can check that these things overlap or don't overlap. So in this case, let's say we are getting the offset and count. Get the offset and counts, and then I can do a both. And sort of see if these values overlap in a way that makes sense to me. Okay, so this is interesting. So the key point arrays have these values. The deformers have offset and count 0, 9, 9, 9, 18, 3. Okay, so the offset and count are definitely increasing. And rotation... 0, 9, 9, 9. Wait, how do both have 0, 1? That doesn't make sense. Where'd 0, 1 come from? Did I mess this up? Oh, mesh. Warp? I'm thinking mesh. Ah, okay, so see. Now we know that those offsets and counts are disjoint. 0, 1, 1, 9. Here we have 0, 9, 9, 9. So those offsets and counts for mesh and warp. And sorry, for... calling it mesh. Should be warp. Find the mesh where anywhere. Not 3 files, this is 1 file. Where's the like find next? Find? Gosh, no, but that's MOC3. I do not know how to use Sublime. Where is the current file? Oh, it does a... That's interesting. But I have... Okay, but add to the backend. That's a very strange way of doing find room replace, but okay. Warp datas. Warp datas. Yes, the type is warp. Keep confusing those two names because I keep thinking mesh. Warp datas. Warp data. Warp datas. Warp datas. That works. Okay, so those are disjoint, right? We have the key point arrays, and those are kind of interesting how they jump across. And then we have the offset and count is different. So we are looking at two different arrays of stuff that overlap. They're unique. And they, you can see that one is about 364 and one's about 114.97. So I expect these to be possibly parameters for the deformers or something like that. Interestingly, for rotation, we have 9 and then 3 and then 9 and then 2. These could be parameter lists. Though 9 parameters assigned to one deformer is a little excessive. But they all seem to have like 13 is the most. That's a lot though. Oh, you have a 39. No, there's no way there's 39 parameters on one deformer. That sounds more like points. Because 3 is a normal amount of points for a parameter. 9 is 3 by 3, which means you have 2. Then 39 is, yeah, I think, are there any parameters with 13 things? That will give you an answer, because that's a very interesting number. Key point. Plus 13 is how I was declaring that. Yes, there are. Okay, so that makes sense. Okay, that makes sense. So this is how they are mapping the this is the explosion thing. This is the multiplication thing. So those are pointers into something that is like these are the key point maps. So we have something like this is the key point array, and this is the I warp states or something like that, like warp I warp, what do I call this? Positions. I warp values. I warp poses. Maybe poses. I actually don't know what. Does Live2D have a name for this that makes sense? Because they have this like parameter palette and they call it rigging key points. You have keys, keyed objects and parameters, and all keys. Keys. Oh yeah, key point is the index and keys. Okay, so it would be keys. That makes sense. I warp keys. And then count warp keys. So this would be I rot keys and count rot keys. And that means that we need to have other arrays that hold these. So this should now be self-evident. Well, what happened? Offset deformers. Whoops. Because we called them differently, yes. So now both here doesn't make any sense. And it's like I warp keys. I rot keys. Count warp keys. Count rot keys. And so now we are expecting those counts to be the product of all the key parameters. And so there has to be some array that has like 1500 and 367. So let's look at our header. Where did I print the hex? I have some silly print in here somewhere that I want to get rid of. What is find next? I still don't know my shortcuts here. Find next, control G. Okay. Yeah, that. Yes. And I probably want to... It doesn't grab values, actually. Let's call it objects. Yeah, and so for the non-class ones, we call them values. So we are looking for 1500 and 367. And we're not finding them. Now that is interesting. Sublime Lang server support name change. Maybe I haven't really figured out Sublime yet. Hello, hello. But these here look sus though. They're kind of close and they are in the right place. It's either those or somewhere. I think it makes sense for it to be these because 1497. But then why do we have so many more? However, some of it does make a little bit of sense. Because you could have the same values for warp as for something. No, that does not make sense. Well, a key point for a warp is kind of the same as a key for a warp is kind of the same as a key for an art mesh. So what if I look for art meshes? Do they start? If we look at not parts, do they have any numbers that start at big? Oh, 1867. Oh, wait, hold on. What were we looking for? 1497. 1874. There's another offset and count here. Those sound like related, but they don't add up correctly though. So this looks like the keys that are for the raw art meshes, but they don't actually add up. So they just start at 0, so they are unique. But that does mean we have 3 things, and we have 3 things here, and so there's an onc offset, and for art meshes that goes up to 511, and we have 587 values. See, it's like a little too much. Why? Okay, do those structures make sense as holding key points? Actually, yeah. Onc 1, which would be for mesh deforms, it should be. We have an unknown float. VBO index, so we know that's where all the vertices are, but it's probably also the it's probably also used for everything. We don't know what that float is. Onc 1. Yeah, so every key for a it makes sense that it has an index into wait, where did X index go? Oh, we didn't print these yet. I think we added the print there before those were added. So this makes kind of sense because we are... okay, so those are indices. Into something else. Do those vertices... okay, so look, we have 80... let's look at this count, because this is interesting. If that's a VBO entry for a warp, which warp 0, the warp that has one key, and this one is 5 by 5 with 36 vertices. Does that make sense? 36 vertices times x and y is 72. And then we have 80 values there. Is that a plus 8? Does 8 make sense? If we have position and scale, that's 4. But we also have rotation, so it's really a 3 by 3 matrix. And so if they have, if they do the vertices separately from the overall size, most untyped Python is I honestly never got into typed Python because most of the stuff I use Python for is just like reverse engineering and, you know, hacking things together quickly. This library, the production version of this is going to be Rust, and I guarantee that's going to be typed. But this is the development thing. I haven't decided yet what editor is going to be written in. We'll see about that. So 8 values. If we have an affine transform, scaling, rotation, and translation. Give me some Wikipedia. I think the final entry in that matrix is always 0. Sorry, always 1. Yeah, that element is always 1. But those are always 0 too, so 8 does not make sense for that. It could be that it is not stored as a matrix, but rather as just raw values, so we would have 2 for transform, 2 for scale, and 1 for rotation, that's 5. It could also be that they're just aligning to a multiple of 8. Or that they're doing something else. We might have some implied, you know, vertex structure here. Oh, also, the keys, you can key more things, actually, in... because they have colors, too. They have colors, too. What can you key? If you go into, if we're in parameter palette, now the inspector palette, so when a warp deformer is selected, because we have the opacity, that should also be keyable. The multiply color, the screen color. And those are keyable. And then we're actually just missing one. If they don't have rotation and translation as separate values, which makes sense because it's already implied in the matrix, then we have 3 values and 3 values for the colors as floats, which also makes sense because I haven't seen anything looking like a color in this entire file yet, which means it's probably stored as a in the VVO data. Well, the way to find out is to actually print them. So let's do that. Because the colors are going to be really obvious there. So if we go to warp data and look at iWarp keys, for example, and just print the warp keys. iWarp keys. I still don't know why there's this interaction here, but whatever. Actually, I'm already printing the key point arrays, and these are the Unc1. So these are Unc1 V. So you can print the Unc1, and then in Unc1, we can actually print the data. It's limited to some amount. And what is the... There's a float here, so actually these X could be the colors. I wouldn't be surprised if these are the colors. Because I think those were added later. Where's the target version? Ah, yeah, multiply color and screen color were added later. So those are actually probably the colors. These are probably the multiply color and screen color, which means we're back to not knowing what the heck is going on with this VVO. So let's just print the data and see what happens. But we need to know how many items it is for the VVO. Interestingly, the rotation. Oh, okay. So the rotation one doesn't use VBOs. These are the rotation params. The mesh one uses. So that should be the array. So what's going on here? Okay. Anyway, let's do. Let's just print that. But I need to know how many params, and we don't know that. So I guess let's just do a bunch. Let's just do like. 16. I can probably fix it so we show the... Actually, no, let's do it at the parent. We print this Unc1 float, whatever. And then in the warp data, we print that, warp keys. And then we say... to the range. Self mock, warp keys. Exit this Unc1, we don't have it yet. I... And the key there, Uncle One, is called VBO. Let's just call it IVBO because I'm pretty sure this is a VBO index by now. Let's call this IVBO colon object IVBO plus vertex count. Wait, hold on. I just missed something. The keys are... Oh, that's the next one. Okay, so we don't actually know how many there are. It could also be that actually those are different things and they're just interleaved and I'm just confusing myself. That is totally possible. Because that VBO is used for everything and it's very likely that these are allocated sort of in an interleaved way. And then, you know, the 8th after that is something else entirely. That's totally possible. I need to use my range thing later to figure that out. So either way, let's try printing this first. And grab vertex counts. Let's just do a little more here, like +8, and see if those 8 make any sense. No VBO index because we renamed that. Where? Okay, so now we have some values. And it is all very random. Hold on, how come it's only have one key? That doesn't make sense. If you have 2 key points, it needs to have 2 keys. I'm confused. How did didn't I just say that those were... Those ranges were... Actually, yeah, I guess it is 1. I mean, that's possible if they never deformed that deformer? So it's a deformer that's just sitting there doing nothing? I mean, that's possible. It's silly, but it's possible. Okay, so let's go to the next one. Here's the next one. So 80 times 336. So this one has, let's look at the sums there. This one has 121 vertices. Three, 2, 2, and then 336 is plus 14. Okay. Did it this imhex? No. Oh. Imhex, I like imhex. I used it. So where am I? The problem is these numbers are very hard to interpret right now. I should make a printer that does like Even NumPy does better strings for these, actually. What if I just use NumPy? Because I'm probably gonna want to do math anyway. And then I can use the like ND array stuff for VBO at least, and just dump it in there. Because I always pretty print arrays in a more useful way. Use normal Python? Yes, normal Python. And now it's slow because NumPy. This might be a bad idea. Okay, but see, it prints much nicer. It prints much nicer. And I can then resize it to like different dimensions. And even this already looks much better now. I can see logic in this. You can see, yeah, look, you can see these are definitely tuples of 2 coordinates. And then after that, there's actually some interesting stuff because that's the same, but those are not. Yeah, I like this a lot better, actually. So this looks like it could be a bounding because this is definitely the same. This is definitely related to this mesh. This is 5 by 5, right? 2, 3, 4, 5, 6. So this happens to line up in a very nice way. Oh, I forgot the times 2 on that. I need to times 2 on that. Okay, now everything is super slow because NumPy. Okay, well, I'll survive. Yeah, okay, so there's definitely related stuff here. 1, 2, 3, 4, yes. So let's grab the vertices out first. And then I need to like reshape this. How do I do that? There's a way of doing that. That's +1. Okay, cool. So now that makes sense, right? So here are... Yes, these are obviously correct. And then what do we have here? 12, 2, 3, 4. Okay, so that's actually the middle. That's actually the middle point of one side. And then we have So why do we have that all of a sudden? Somehow we are starting over here, and we have more. That starts with minus 0.200. Where'd that go? Oh, did I only print 8? Oh yeah, I only printed 8. Wait. What? That's not 8. Oh, because it's a peak. Oh, I'm done. Okay, sorry. Ah, I made a mistake. Okay, try that again. Okay, so the other ones are all 0. It might just be padding. It might just be padding to a multiple of 16. That would not be entirely surprising. That it's literally just padding. Because that's a multiple, right? Yeah. It might just be padding. Because that's 3 to 2. And what did we say we have? 150? 336? Oh, I think it's just padding. I think it's just padding. That's all there is to it. Yeah. Okay, it's just padded. It's padded to a multiple of 16 vertices. For alignment purposes. That's all there is to it. And so we can verify that by just looking at in Unc 1 IVBO. Yeah, that's it. It's just padding, so there's no mystery. It's really just the data. So then we have the answer. Then we have the answer. Mesh keys. Mesh key. This is what this is. This is IVBO start to be correct. Well, I'll just say IVBO. I'm too lazy to say start here. Mesh key. And this is rod key. And the other thing is, I don't know why they're like unused ones at the... Not mesh. I keep calling it mesh. Warp key. Warp key. Warp key. So it starts. And this means it means that's why this was times 5, because they used 5 key points for every single rotation deformer. And so that's how we ended up with that. So then we don't know 3, I think. Warp keys and rock keys. so these are probably the colors into an index of colors. I'm gonna put some markers here about when the updates happened. So these are the multiply and screen codes. So this is 4.2. Blend shape. And these remaps are the blend shapes. That makes sense. So these are the limits. That's why these exist. So I have to rename those. And then they added more blend shapes later. So I'm guessing Ang3 is art mesh keys. The raw ones. So then we can do the same thing for the raw keys. Let's say V here. Oh no, because V is whatever. Rock keys, append to V, and there's no verses for these, so we just drop all that. And so then this is nothing, and print it, raw data. There we go. Now we have something going on here. I actually think a lot of the time printing is just because it's dumping all these numbers now that it wasn't before. Do I have an N squared anywhere? I think in here I don't. Hopefully the numpy stuff itself doesn't do that. And am I don't think the print here does. The SDR, no, it uses append. It's probably okay. This will be a lot faster if I just do this. Yeah, so now we have the warp keys. And those are just the XYs. I don't know which order they're in, but that'll be easy enough to figure out. And Yeah, so those are all the keys. So it's really starting to sound like this is really just the project. The way that the formers are done. I mean, it makes sense in this context. Like, I thought they would be baked into blend shapes. But actually, the way this nesting works, it doesn't make sense to bake them into blend shapes because it's actually faster to follow the chain and down to the art mesh. So yeah, this is not very baked. Okay, so now these key point arrays, this does not make any sense. We need to have what these really should be is parameters. And if we have multiple dimensions, we need to have multiple entries in that thing. So if we have yeah, so for example, this one has 3, right? So that's one parameter. So there's one that has a lot. Like, that's 9. Okay, so that's 2 parameters, right? So this has to be wrong. Because this is not pointing to the right thing, this 13. It should not be a key point array. It might be a key point array pointer. Or a parameter pointer or something like that. But we need that. What we really need is a list of parameters. So this is not right. This is not right. So this pointer is not right. These pointers are equal, but that 13, what I really want is a, I thought I had a, okay, there's L key point arrays, list of key point arrays. Isn't that what I have? I think I just messed this up. I think this is a pointer, not to the key point arrays, so the L key point arrays, I think. Either that or the other one is pointing into the list. Let's try printing like that. See if it doesn't fail. Oh, maximum recursion depth. Oh wait, why is this P key point arrays? Oh, maybe it's a pointer to the list. Okay, this indirection is weird. But okay, so let's try pointing into that. If this is an IL key point array, that would make more sense. Let's see if those add up. Yeah, so this one has 0. Yes. 0 because there's no maps. Then the next one has 2 and 9 keys. Okay, yeah, that makes more sense. That makes more sense. Okay, that's what that is. So this is an IL key point array. That makes more sense. And it's the same for this one then. This is L key point arrays. I L key point arrays. And say L key point arrays. Okay, this makes more sense. So now, the question is, how does this map to parameters? Because these have to be parameters. Which means we need to be able to go from parameters to the key point arrays or back, and there's that weird pointer thing. So let me look at the counts of everything again and dump a little text file here I can look at. Oh, that did not work. Validate, L key point array. And then we have those at the end here. I, L key point array. So we already figured those out, the keys. Let's print all the arrays then. Deformers. So we have the just print that. Yeah, it goes to 1 to 4. Yeah, 1 to 5. Okay, so that is definitely correct. It's a point. I messed that up. It's a pointer to the key point arrays. What's going on with parameters? So we have 162 parameters, and P key point arrays sounds like an indirection from parameters to key point arrays. So why would you need that? So they added blend shapes at one point, so let's look at param, because there might be some hint where like some parameters, maybe blend shape parameters come later, and so that's why there's an indirection there. Param, there's no extension here? No, there's not. Okay, so they, I have an I key point array and key point array count, but that does not quite work out. How do param arrays and counts work? Is that really like that? No, because params only have a single key point array, so that does not make sense. So those are different. So let's assert that to make sure that we know what we're doing, and do a print at the end of the param arrays. Params.I key point array. And the count, and print all of those. See if that makes sense. -1. Okay, that's interesting. Okay, so those are clearly not they all have a 1. Okay, no, that is a count because we have 70 and 72. We end at 128, which means so it has to be a key point arrays. Okay, I'm gonna take a quick break. I'll be right back. But that looks correct. So we have a Somehow parameters can have more than one key point array. That is interesting. Let's see what happens. Be right back. Alright, I'm back. I'm gonna eat a little more because Cyan's gonna be mad at me if I don't finish my food. And I still have some bread left. Okay, I just realized something. So remember we have these, this is what I'm looking at this, these extensions. These have to be the colors. And I have these two arrays called unknown skin and unknown translate, which I call them that because these are all 111 and these are all 000. But that could just be white and black. So I think, before I continue eating, let me fix that. I'm pretty sure those are the pointers to the multiply color and what do they call them? The multiply color and the screen color. It's weird that screen color. It's something you have like multiply and add, but I don't know. Like a screen makes sense. So those were added. Multiply colors and screen colors. And so then, which is really funny how they don't deduplicate these at all. Like you just remove all the junk from the file just by deduplicating these, but they don't do that, which is really silly. So that also gives us a hint as to where they added those. Because I can go back to target version, multiply color, and screen color. Those were 4.2. Same as the blend shapes. So blend shapes should come in somewhere here. Probably ended up here. Yeah, those are those are the color extensions. And glue is... I guess glue was already there. So glue was added earlier. And I don't know about the reverse mask. It doesn't say where glue was added. Just that they added blend shapes to that. So, it's also possible that they don't actually handle this like strictly in an append-only fashion, and because if they did that, this would actually be backwards compatible to an extent. But I get the feeling they might not be very strict about this. Wait, that's also 4.2 plus. That doesn't make sense. Hold on, we said the remap arrays, those are blend shapes. Oh no, that's blend shapes are 5.0. No, 4.2 have blend shapes? Oh, those are, they maybe add the limits in 5.0? Let's see what they, Cubism 5.0 release notes. I get the feeling they're, they are not very good at documenting these things. Enhanced blend shape. Okay. Where's the limit stuff for blend shapes? Keyform editing. Limit settings for blend shape weights, yes. When did they add those? I bet they added them somewhere, they didn't say when. Because if I go for Cubism 4.2, it already has that. So maybe all of this is 4.2 plus. Sure. What got added to warp keys and rod keys? The extension. Oh, the colors. Yeah, okay, yeah. So these are the colors. Yeah, okay. So all of this is 4.2 plus because it had to. So then warp data's. Wait, what was warp data's? Warp data was. Extended with a bunch of things. It's possible that, oh right, because these are blend shapes. So blend shapes wouldn't use the regular keys with the multiplication. So these have to be all the blend shape parameters. So what this means is that these are probably basically the same thing. These are the blend warp keys and count warp keys. So all of this was added in 4.2. Custom workspace. Cubism 4.2, what was added? That says multiplying color and screen color were added though for those with the blend shape. So what about 4.0? See, reversed mask is one that would have been inserted here somewhere. But glue, I don't know when glue was added. Cubism 4.2 release. Okay, so that's the first thing. Additional functions, UI, modeling. Okay, they added blend shapes in 4.2. Yeah. And the colors. So what about the previous one? Okay, 4.1. Is any mention of glue here? Fixing things. In 4.0, they added mask inversion feature, extended interpolation, that's edit mode. So they added like a flag to the mask somewhere. And then I don't know when they added glue. Maybe they had a free flag they weren't using and they just reused it? Or maybe they just didn't bother having that incremental. It could be this art mesh. The first extension was zeros order optional index. This could be the flag. I don't know. Maybe they reused the flag. Maybe they had a free flag and they reused it. And I don't know when they added glue. Added onion skin form animation workspace. Okay, so they didn't actually... They just added the inversion thing. Not much. When's glue added? Okay, that's when they added it. In 3.0. So I didn't mention that, but glue is added there, probably alongside this art mesh thing. Art mesh and the former can be edited. Okay, that's just editor. Draw order group. So this order is probably the draw order groups. Probably has to do with that. So then there's probably a flag here for the draw order in art mesh. So then they would have 5.0 is bonneted blend shapes. And that's probably here. Because they added the number 3. And this is probably... Yeah, this would be the link to the blend shape things. So I'm guessing this is all the blend shape features. And then this is the base. Except they added this parts 1 there, and that would be unknown, but the depth, that probably was there much earlier than that, or they just did it like that for some reason. They don't have the link to the 2.0, but I don't care about that. Okay. Yeah, because, I mean... it doesn't make sense to not have warp keys and rotation keys. So this part's expansion for some reason is there, but it doesn't follow the version history. Okay, so now we have a rough idea of when things were added. And so this is all going to be the blend shape stuff, which fills in a lot of unknowns. Okay, so going back to the story here, we have warp data. So there has to be a flag for the legacy stuff. Quite likely this one. This is unknown. And that legacy thing was added when? Where am I? Deformer, warp deformer. 3.2, 3.3. They added that with 3.3. So I'm guessing that warp data extension is from 3.3. Or it was in the deformer. Does that make sense? No. Those are added in 4.2. No, that doesn't make sense. Because... Or does it? If they added blend shape stuff to the keys... Does it make sense? No, those are just the colors. Yeah, so I think they are not fully respecting this. Because... They need to have a list of at least key points here. It's possible that these key points are then referenced as just regular keys, and they're just additively blended, so they just get tacked on at the end of that. But then this key point array doesn't make sense. Unless they just added it as like a companion to it. But I don't think they did. Did I mess this up? Because this doesn't make sense. The screen colors and multiply colors should be in the keys, not in the datas. Unless this is just not sorted right. This would make... I feel like these are swapped. Maybe they messed it up. Maybe these were supposed to be the other way around and they messed it up. Because I don't think the files are actually backwards compatible, so... They're supposed to be upwards compatible. Hold on. So let me just look at the sizes again. So right before this glue stuff. We have art meshes, and then they added warp datas and rod datas. Oh, no, sorry, it's after that. It's after glue. Confusing myself. After glue, we have a bunch of ones and a bunch of indices. I think that's part of glue. Yeah, these are keys, but maybe they just have this backwards. I think they just have it backwards. Or I don't know. Anyway, let's just keep looking because I'm really just guessing weirdly now. Either way, the numbers here do add up. So so I know the mappings are correct anyway. So yes, these are extensions of the datas. So we'll look at these labels later, but for now let's go back to numbers. So we are looking at UNC3 should be art mesh key. Yeah, and so then this is an index into the key. So that makes sense. Let's just start. And then let's print the colors like that. These are called multiply. So these are art mesh keys. Art mesh keys. So art mesh keys. Yeah, so this is Vec3. These are the colors, but this is. I guess I can just replace Vec3 with color. Yeah, they call that RGB. Yeah, so now that makes sense. And we can just have a STR here that's less annoying. Okay, so we have the colors, art mesh keys, and so art mesh should have a pointer to the art mesh keys. And the key points. So this does not make any sense. This should be an it should be a that should be the pointer to the keys. Oh, why are they pointing to the same keys? That does not make sense. How many do we have? The data is we're looking for a specific key point array, and then a number of keys and a count of keys, and then yeah. So that Arthur should have that somewhere. Give me this offset and count. Yeah, that makes sense. And this is probably the key point array, I'm guessing. Okay, I'm just gonna try that. And let's actually validate this. Art mesh keys, art mesh keys. Okay, so that one has 1 key point array and 2 keys, and we should be where is it not indented? It should be indented. Oh, it's 3 times 8. I don't know why I made that 4. Actually, no, it should be 4 because I keep changing my mind on that. I guess I should just print it at the keys there. Yeah, I'm supposed to put those there. Indent that by 4. Okay, like that, yeah. So 2 keys, and that is the depth. Okay, so art mesh key has the second one is the depth. And the first number, what would that be? I wonder. So sometimes it's 0, 1. Oh, opacity. That should be opacity. That should be opacity because, yeah, of course, it makes sense. Because you can turn them on and off, and some parameters are gonna fade art meshes in and out. So that's opacity. How many affine transformation matrices? None, actually. I have found 0 affine transformation matrices, and there might be none. No, actually, this one. This is the only one. This is probably an affine matrix, but I haven't looked at the numbers yet. I think that's the only one. We can look at that in a sec, actually, and see if those numbers make sense. So float 1, float 2, actually opacity and depth. And then we can call this IVBO. Yeah, and so opacity is that, depth equals that, no parentheses. Yeah, so then we have 2 key points and 4 of these. So that's how the multiplication stuff works. So I can add validation of the number of keys. And the best way to do that would be the L key point array. I can have a property total. Interesting autocomplete there. I had no idea that's a thing. Total keys. And so what we do is n equals 1 for I in self dot not raw data. What am I doing? L key point array. Where is that? List of key point arrays. And I'm gonna have to rename these because this is really like a parameter range or something like that. I don't know why it's separated out like that, but for I in self dot, I can range start. So let's count. And times equals self dot mock dot p key point arrays I is it through pointers? I guess it's through pointers. Dot I guess this should be a property here. That's not what I want to do. I want double editing. And so then I can validate that the number of keys here is correct. Actually, I'm already doing that, so I can just check that and let's say, key dot total keys. Yeah. Key is only a subsection of the array? No, key is like a set of positions for a given item. So it's a coordinate in the multidimensional space of all the parameters that are assigned to that item. So does this fail validation anywhere? It does. Name counts not defined. Okay. And I don't need to run this stuff at the end anymore. Count is not defined. And then a certain error on the art mesh. So this is failing. Ah, because I forgot to return something. Ah, now it works. So that validates. Anything else that's failing? No. Okay, good. So then those remap, let's rename that remap values thing since that's bothering me. Those are the blend weights. So let's change that. Blend weight arrays and blend weight values. No, it's got maps actually. And then probably that unknown in the maps is the source parameter or something like that. Yeah, that makes sense. So 42 in this case would be one of the other parameters, and we don't know which one. It's either a parameter or something else. Like, just stop printing some of these things. This is got I pair maybe, because you only have one of those here. So, Nani? Unk. What's an unk?
What's an unk?
Good question. I don't know what's an unk.
What's everybody saying? Oh, it's unknown.
That's the point.
So this is a. I drink soup. Hey, you didn't like the bread.
It's it's just I'm full.
You don't have to. You can leave it for dinner. I'm running the dishwasher. I just need plates. You sure you want to finish it? How about the soup?
Maybe later.
No, I'm eating it and I'm putting
Okay,
it in
okay.
the dishwasher.
Okay.
Do you need anything?
That's it.
Hi, Mary.
Hi. Okay. Starting to make a lot of sense. Damn, we know what all these things are now. So the text chords I have as flow 32. I don't know if those are text chords. I think they probably are though. So let's go back to Art Mesh. So we know these are correct for sure, and I need to verify. Am I verifying those? Yeah, I need to verify those as for the former. And actually, those are the same. They don't have type info, so there's only one. So let's validate the parts. And the deformers. Those should be optional. So I think the text cord stuff makes sense, and we can look at art mesh right now. Whoa, the formers where'd that go? I need to get rid of some of the prints. So actually, let's go back to the mesh. I'm just gonna clean this up a little bit. The warp deformers. Let's add a property for the. Not a property. Let's just add a get key. Key mesh, yes. Get key mesh. Actually, you can just say get key and return that from here. Get key I. And in that here. And then use this as can or 60 times 2 points mesh. And you can just return this reshape. Because I'm gonna want to do that also for the art meshes. Yeah, so that works fine. And so I can just not print that because that's going to be really annoying. Like that. Yeah, see, it's much faster now because that was one of the big things I was printing. So you can get the mesh now, but we don't have to. So art meshes, we have the keys. So does this IVBO make sense? Probably. We have 74 texture, basically 74 vertices. And so that's 148. 332 and then 344. Yep, that's exactly what it is. So this is actually the vertex count. And then this is probably just the offset into the text chord array, which I think is different to the VBO. And then we have the index buffer with all the polygons. So this is vertex count. And this is text chord. And it is the count IBO. And it's 4 per text chord, which doesn't make sense. Because I would expect it 3 for triangles. Actually, for a regular rectangular mesh, I would expect 6 per 4. Wait, 6 per text chord. But it depends on what kind of mesh it is, because yeah, if it's just one strip, then you would have 6 per 2. Yeah, it still makes sense. So those are probably just the it probably uses triangles. However, is the count always a multiple of 3? Hopefully. Yeah, I can add a verifier for that. So it's always triangles. So let's validate that. Yeah, it validates, okay. Let's make... Oh, did Sublime just die, or did I hit the wrong button or what? Anyway. Let's add another check for that, so I can say assert... I can just say, actually. Self.mock.text chords. Self.itext chord plus self. Text count plus 1. And then IBO. IBO. Nah, I think it's just triangles. I don't think they're smart enough to do optimization to strips. And it doesn't mean it's multiple like that, so. Because the thing with strips is, if you use strips, then you need to use the index buffer primitive restart. If you want to use triangle strips, you need to use the primitive restart feature, and primitive restart is like an annoying thing that would be silly to require in a generic model format. That's why you don't do that. Either that or you have to separately encode every single strip and submit it as a separate draw call, and that's also a really bad idea. Okay. Yeah, I mean, I know most real GPUs do primitive restart. But not all of them do in all cases, and there's, okay, I was involved in a GPU driver, and I heard the term primitive restart in very annoying places multiple times. I want to say it's not a thing you want to rely on. It's a painful edge case in multiple cases, so I just did most of that, but I remember it being a pain. Yeah, see, Mary knows. Mary knows about this. We're really getting somewhere, though. We are, Okay, next up, let's look at those rotation vectors. Rotation keys. Okay, so we have a bunch of values here. What is going on here? So the first one is probably opacity. So let's just do this separately, because this, as an array tuple, is a little bit... Is it a little bit? I'm not sure. Let's do it. Okay, we can do it here. Opacity. How did I do the mesh ones? The warp keys? And it shouldn't be called float. Opacity. This is obviously opacity. Let's do these separately. Opacity, and then we have 6 values. So those are, the second one is probably angle. And then everything else essentially should define an affine transformation. I mean, everything should, all of this together is an affine transformation, but I don't think it's encoded as a matrix. We have 6 values. And 2 of them are 0, which are probably translation, because you would expect a trivial translation for some cases. Or maybe that, okay, that one there. Okay, this one's interesting. This one has... Those second ones look like translation, and then the third one looks like scale, and they probably don't do a fine scale. So, yeah. Yeah, I think so. So the first one is rotation. The second two are translation. But then the next question is, where's the rotation center? Because there has to be a center of rotation for this to make any sense. Unless they, does that make sense? No, that does not make sense. They need a center of rotation. So that has to be declared somewhere. No, you can chain them, but the problem is, how does the interpolation work? Because I don't think translation and rotation chain with linear interpolation. I do think you need two separate translations. You need like a pre-rotation translation and a post-rotation translation at least. For them to interpolate properly. It's a weirdly tiny value here. That looks like a really tiny scale. I wonder what that's about. I mean, yeah, with 3D you just use matrices, but this isn't a matrix. Because the whole point of rotation deformers, if you use the matrix, it would be equivalent to a warp deformer. Because when you linearly interpolate a rotation matrix, that is it's all linear. It's equivalent to linearly interpolating a mesh. The point of using a rotation deformer is that it is not linear interpolation in affine space, is that it is applying a rotation and interpolation in terms of angle. And so for that to work, you need a center of rotation. Unless they literally just translate the children. If they just pre-translate the children to always be rotated at 0, 0, then it would work. And then that's kind of easy to find out. We find someone with a parent that is parented by a rotation and see if the array of key points looks centered around 0. And if it does, then that's what they're doing. Which would make sense, because it's an optimization. Now, of course, you could still rotate by not centering the mesh. So that doesn't necessarily mean it's going to work like that. Yeah, I think that makes sense. I think that's probably what they're doing. And it's possible that these two numbers at the end are actually the other translation, and it's a 0 because it is always baked in. That would also make sense. So the question is it ever not 0? Oh, is he doing now? Doesn't look like it. I can look at imhex and see it there anyway. The something, that's the something 3, no, the unk. It's these. It's the 6 and 7. Oh no, this does have some stuff. I know, that's unk 3 float 1. Yeah, that's always zeros. And that's always zeros. So it's possible that that's actually what that is. I think that would make sense. We're just going to assume that's what it is. So we have then angle. Oh, and there was also an initial angle, but that should be in the rotation deformer. So we need a... This unk float is probably the base angle. That's probably the base angle. Does that make sense? Shouldn't be necessary, really. Anyway, let's set these up like that. So we have... Yeah, -0. Okay, yeah, that looks like a base angle. It's probably a base angle, yeah. They call it the fixed angle. You could just bake that in, but I guess they... Or even just angle offset, maybe? Because you only see 0 and -0 there, so that makes sense. So in rotation data, and it makes sense because like what probably happened there is the base angle. I bet what happened is the base angle was plus or minus something in the editor, and then what they do is they apply transformation to cancel out the base angle, and so that gets added back to the base angle variable, which means you end up with 0 or -0 depending on whether the base angle was positive or negative originally. So they probably are just baking that in, and that's why the sign is left over there. I think that makes perfect sense. So we have angle, and then position, which would be an array tuple of like x and y. So by translation. Scale. And then these are possibly pre-translation. And similarly, those are always undone. Yeah, that makes sense. So are you failing any verifications? Nope. And then position is the issue here. That makes sense. Yeah, this is all looking quite reasonable. Okay. So then what got added to this rotation key? Okay, I think I know what this... I think I know what this raw data is. I bet what this is this is the... probably the key point array list of mesh parameters. Because what is different about that is that those are how many key point arrays do we have? $152. No, that does not work. But there has to be something added there at some point. Where they have the blend key points. Okay, so the next thing I want to figure out is how do we map key points to parameters. Let's go forward here. We just did art mesh, and art mesh is getting there. There may be flags here for I don't know what unto type is. Let's look at art meshes. I want to fix home and end. How do I fix home and end in here? Terminal, home, end. There's a thing. Terminal, settings. Okay, home and end. Didn't I already do this? I think I did. Oh, and it doesn't work with less is the problem? That's why. Okay, so I guess I probably need to do these. So it's escape that H. Okay, so does that work with ZSH? Let's delete that. Escape that. No, that. And F. No, that does not work. Thank you so much for the super chat. Thank you. Why does it not work in less? I guess I need to change the term. And yeah, I just need to change the term in this one. Okay, first of all, does this work with the SH? No, it doesn't. Okay, so I need the 1 and 5, control. So I have to leave those in there for the shell to work. Unless I change my ZSHRC, but okay, so that works. Then how do I fix that? Huh? Does not work. Does not work. How? How do I do home and end and less? Make it fix. Make it work. Oh, this works on Linux without messing with it. What's this doing there? There's a less key file. And even page up and page down up and page down do work. But I want home and end to work. Let's key home end. There we go. So we need that. Go to end. Okay. Is there a default file name for this? I mean, I know I can use other keys, but I want to yeah, so this is the command. It's doing forward by default, which is not what I want. So it doesn't work with less keys? Says go to line and go to end. And it doesn't work. Why is it so slow? What's going on here? Ah, semicolon, sorry, not colons. Ah, it works. Okay, yes. So, now I just need to put this into a less key file. And insert is not doing the right thing here. Yeah, I need to fix insert 2 for Vim, but I'm too used to using insert. Control A. Okay, so hopefully that fixes less. I hope. Yes, that fixes less. Okay, so less is working fine now. Yeah, I'll survive with that. Okay, good. Little detour there. Okay. So now home and end work, and then I don't have to keep scrolling here because I'm too confused. Okay, now back to what I was doing. So what's going on with the art mesh? What's Unc2 type? We have 4 and we have 6. Why do we have 4 and 6? That does not make sense. It could be the blend mode. But 4 and 6 sound like really strange values for blend modes. Now we also need a the clipping list, and we definitely have some interesting things going on here. Okay, so what's Unc 9? That's after IVO. What does that have? Those are just ints. And single ints is a really weird thing to have at value. Okay, I'm gonna take a very quick break. I'll be right back. But this is possibly related to depth. We'll see. Be right back. Okay, I'm back. So I think this could likely be the clipping list. If there's a count somewhere. See, there's a 1 there. No, that doesn't work. So we have 168 art meshes. And the clippings go to 108. So that does fit with... and this is interesting. This Angtan has these values. So these do fit with art mesh IDs for clipping. But then we need a count of the number of clipped objects. Unless they added that clipping feature later and we only ever have 1. Yeah, oh, 23? No. There's no flatbed, that doesn't work. 23 is too big. And it jumps from 3 to 10. Which doesn't make sense. And then there's a type after the texture atlas. 4 or 6. I mean, that could be the blend modes. Okay, how does clipping work? Let's go back to here. Inspector palette. So there's clipping ID, reverse mask. And group 3, that is an addition. Where was that added? That was added, oh, I just realized something. There's this UNC order, and We have 2 art mesh counts for some reason. It's possible that that was actually an extension. And so that extension is, in terms of order, so it's a different object, and that's why it's pointing in a different order. And so that one is the count is right before glue. So it should be this one. It should be the first extension. But that now points to order. So that kind of sounds like it's pointing to an art mesh. Is this like a linked list of did they ever add a clipping, multiple clipping thing? Was that an update? Maybe it wasn't. Yeah, maybe it was in 3.0. Yeah, I wonder when this was added. So I suspect they probably didn't do this in 2.0. Okay, so 2.0 new features. There's a YouTube video. Where was my link? I list somewhere. I think I did have the 3.0 somewhere. Hold on. It was at the end of that. Yeah, so the added blue. They added draw order groups. So that could be the related to that. Okay, what's this draw order group stuff? Because that might be related. Now this is a Boolean, so that's not terribly interesting. Well, I mean, the optional index makes some sense as a clipping path, but I assume, I mean, this model has to have clipping, so I assume. And come to think of it, where's the depth? Oh, that's in the, is that in key points? That's key points, yeah, so okay, this is 500. For pretty much all of them. So this model doesn't use the depth controls. But then they have these links to the order in group 1. And they don't go anywhere. I feel like that is a separate object. And then what about this index? This index goes to 2378. Oh, it's probably multiply color and screen color? Because those were added later. But those should be per key those. So, but maybe it's the blend modes. Because that was added on... Yeah, that was added here. So that should be the blend... No, the blend mode's not here yet. The blend mode was added in the version I don't have. But this was added with the colors. And each one is 2. It's almost like a vertex. So it's not a vertex ID because that those are those holes don't line up. It's not a text cord. 1867. Anything that ends there. Oh, okay. These deformers also have an unknown index that... starts there, so that's the same. Okay. So something was added to both rotation deformers. Okay, this is, yeah, 1846, 1849. Okay. Okay, what? It is this. That has to do with keys. Oh, okay, this might be the blend shapes. That would make sense. That's why it was added later. Ah, no, but that is increasing by 9. It's increasing by the number of keys. So it's actually an extension to the keys. Okay, so it's an extension to the keys. 59, and then plus 3, 60. No, it should be 62. Where do you get 64 from? No, that does not work. How do we go from 1 to 9? We have 9 warp keys. And 10. And then 41? Okay, let me write these up as something different. So those are, I'm pretty sure they're all in the same type of object. So unc other index, unc shared idx, unc shared idx, and use this for raw data and also art mesh. Ah, okay, there's a jump there. That's why it jumps. Okay, so let's combine all those. See what ranges we have. We have warp data. We have rot datas. And art mesh. I'm gonna split these into like a string one and a non-string one. The string one would be Make sure they don't intersect. Yeah, they don't. So we have these numbers, and the final counts we have are these. So, let's look at those and see if the counts make any sense. So we have 0, 1, and then 10. So 1 has 9 for some reason, then 10 has 1. Okay. And then we jump to 41 because other stuff happened. But 41 has 1. Okay, so we're still on the number of keys. And 44, yeah, okay, so it does work with the number of keys. And then 59 plus 3, yes, okay. So it is that. What is this array indexing into? 2, 3, 7, 8. It's like we have some mystery junk data that doesn't go anywhere. Okay, so 2, 3, 7, 8. That's in the art meshes. The previous one is 7, 5, and that added 3, so that makes sense. So 2, 3, 7, 8 plus 3 is 2, 3, 9, 1. Nothing. What could possibly index into like 2, 3, 7, 8? That was added at the same time as the... It was added at the same time as... the colors. So you would think they could be indices into the color. So hold on, wait. Are they just the default color? Is it just the color of like the first reference? Let me print those because I'm not printing those right now. Oh, it's just the first color. It's just the first color. So I guess it's like default color or something like that. That's really silly. Yeah, I have no idea why they have interaction and then they have the same color a million times. It's really dumb. So it's just first color. First Multiply color. Why is that even a field? And then they don't have the same thing for the screen color. Or is it just because it's the same one? But then why are these separate? Yeah, we can add some checks for that. Yeah, that verifies. Okay, so that's rather boring. But at least we have that. Still don't know how clipping works. It could be that this model doesn't use any clipping. But there's something going on here though with this 9. So
When do you want dinner?
when I'm done, because I'm not hungry at all right now, so.
Are you done with this?
Arigato. This undo type doesn't really show anything. I believe this is before they added the blend modes. I think because this is version 5. And when did they add the blend modes? 5.3. Wait, no. But in shape, yes. Blend mode is 5.3. End of screen drawing. So I suspect this is I suspect this is still done with 5.0. So they should not have blend modes. It should have the old blend modes. Like if I go to 4.2, it should show that.
And then the babies tend to be dragged around by water, like
Yeah.
like they can't rest. Everybody is flying.
Okay. Can you just turn off the pump for now, and I'll look at it later. Follow the cable. It's a USB one.
I can't kill them.
No, you're not gonna kill them. It'll be fine.
It'll be fine.
It'll be fine. Okay, so yeah, we know there's an inversion. The inversion is a global, so inversion 4.0. Okay, so they added inversion in 4.0. So that should be something we see there in So that's 4.2 though. It's possible they added this in 3.0 and then like, hold on, art mesh, where are we? Art mesh. Now this is the weird order thing that I'm not so sure about. Which might be related to clipping. So this could be a clipping thing. Order doesn't make sense though. But maybe it was just a flag they added. Maybe this, okay, this Antu type thing, this could be a bit mask, because 4 and 6 sounds like a bit mask. Maybe that is a weird thing like that. So what's going on with this Ankh 9 though? So how do we go from 3 to 10? Ah, wait, hold on. Is that the 6 thing? So this one increments from 0 to 1. How do we jump to 10 though? Okay, it looks like the 6 here has something to do with this incrementing. Yeah, it has something to do with that incrementing, but not always. And then what's at Ankh 10? Because Ankh 10 is of type... just a bunch of ints. 0, 169, 169, 500, 400. So 169 is the number of art meshes. And then 500 and 400, I have no idea what those are. So this could be like a sort order related thing. I feel like this has something to do with that art mesh mapping thing. And 500, 400 almost sounds like a group of depths. Is it possible that this is so that you can have more than one top level character somehow in a... file? Because Onk10, I think, is the last thing before they started expanding. So it would make sense that it is like a root element of the entire thing. And so then you have like starting art mesh and ending art mesh. Like maybe they support multiple characters per file? And then these could be dimensions, 500 by 400. Though I think my model is higher res than that, but I'm not sure. It might not be. Well, let's do a quick check. What is this? NAS, Dev, MOC3. And also there's some weird stuff. I think this model has textures that aren't supposed to be there. It might. Let's see what's in here. Oh, and there's actually a signature in the file. It's funny. Yeah, it might be pretty small actually. It's not very big. It's a very simple model with lots of empty texture atlas space. I mean, it is at least a few thousand pixels wide though, so it should be around yay big, so 1500 by 2400, so that size does not quite add up. The atlas is 4K, but you know, the actual canvas would be different. However, it could be a depth thing. So these are the user friendly names for everything, which we could add. That would be useful. I would just have to translate them. So, yeah, this Onk10 thing kind of sounds like a top-level structure. Thing is, because there's only one, the only index is 0, so if anything references this, I have no idea. But I think it makes sense for it to be a top-level something, because also, like, there's this top level here, right? Now that's this group, but Is there any kind of like top level settings? Like anything global at all in this file format? I don't think I saw 400 anywhere, but let me grab. Ah, yes, there is a depth. There are depth 400. Yes, there are key forms. This depth 400. So that makes sense. It's a minimum depth and a maximum depth, and like it's like a global stats really. What's environment settings? Okay, that's not for the file. What's project? Okay, that I like that project tab. What is that project tab? Project palette. Ah, okay, that's storing the source files and stuff. Yeah, I think it's some kind of global thing, so we're just gonna assume that's what it is. Because it's possible that what happens is that when you import multiple MOC3 files into the player, maybe it's set up so I can merge them in memory and then like display them at the same time without having to rebind different objects on the GPU. That would kind of make sense. No, I cannot touch their SDKs. Watch my first video or the FAQ. This is a black box reverse engineering project. I cannot use any software licensed from Live2D. I'm looking at their website because their website, there's no click-through ULA or anything like that here. But I am not using any other software. So we have those, and then it's like max min depth, I think. Yeah, max depth. So I think that is really, this is called top level. Or even like character, model. Let's call it model. Model. And we don't even need to do that, we can just show everything. So model. 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 Ah, this is H struct. Okay, so that's just the, yeah, that would be the top level model. And that leaves us with this weird Ang9, which, let's see how that increases. So this looks like a count of possibly art meshes. It would kind of make sense for it to be the clipping masks. Hello. Okay, so we fixed that. Let's open these up. And looking through the art meshes, so you get 0. And then 29, mesh 29 is referencing this value of 30, so that's already kind of sus. Sorry, it's, yeah, 35. 29 is referencing 35. And then, 33 is 35, and 34 is jumping to 35, and then we have 35 references 53, and then all those reference 53 until 59, and then it jumps to 10 to 64. So there's a 53, 54, 55. So something has like a count of 10 here somewhere. Okay, I'm kind of seeing a pattern here. The pattern I'm seeing is that the art missions in order, this number is kind of like a reference to a limit. So if this is 0, it's saying the art meshes from 0 to 29 are related to all these art meshes before them, right? And so, then we have 35, which means starting at 29, we are like kind of increasing up to 35. And 34 references another 35. Hold on, is there, what's the last value of that? 20, oh, it's 23, it's 23. Okay, so that's interesting, right? It's one more than the number in this array, which kind of tells me the previous number has something to do with it. So I think this is a set of dividers across the art meshes. These are like breakpoints between the art meshes. So some of this art mesh is, I think it's referencing a range from 0 to 30. Because this index is the end index in this array, and there's like an implied 0 and an implied total art meshes at the end. I have no idea why they would do this. And so when you hit 1, that means art mesh 29 is referencing the range 30 to 35. As are everything up to 33. And then 34 is referencing the range 35 to 35 somehow. And then 35 is referencing 53 to 35. Oh, look, now they have these extra group 1 things here. And it jumps to 30 to 59, 2, 1, 0. And then 1, 1, 7. That's weird. And then this jumps to 10, which is really weird because now this doesn't make sense. Why would it jump? So these are not indices, so 60 is jumping to 64? And then this goes back to 30, which doesn't make sense. Hold on, so when does it jump to that? It does 10, then 12, then 13, and then 14, which is weird. I do not understand this. Is it really the key points? Oh, I don't get it. Why does it jump up like that? I get deduplicates sometimes, but not others? And then this is bothering me because this kind of looks like it could be related to that. Like if I interpret these group 1s as something else, but then why would it have a number that is greater than the max? Okay, let me print a little bit here. At the end, if I do, okay, so we solved those. Zeros should always be zeros. Order and then optional index. So I suspect that these are different objects, and then there's something going on here. So those are always 0, that's always -1, and then these are possibly the same as the art meshes, but they're in a different order, I think. And I might want to print them separately. There's like this remap of art mesh orders going on. Okay, so now there's one thing I've been not doing yet, and this is interesting. So I haven't printed the parts tree yet. I want to do that. So let's print the parts tree. Let's add a function for that. Can probably just kind of do it from the parts, from the part thing. I just need to find the roots, which would be the parts without parents. So I think I can just do it in the part. But this one doesn't know who the parents are, so I need to like build a tree out of them. Yeah, that's one thing is it could be order based on depth, but the depth is mostly the same. However, the default is to render parts in the art meshes in the order they're in the part tree. So I want to see if that is the order that they're in. So let's do some kind of tree print thing. To do that, I need to know who the children are. So I need to add let's do like a self-build tree. Let's just add a generic children array there that we can reference. For I in self parts, if I dot I part parent is equal -1, and I just realized the children have an order, so I think in terms of parts, they are always, the tree is exported in order essentially. I can validate that actually. I can assert that it is always, the parent is always printed first. I believe that is true. I and self art meshes. There's I part and I deformer. I part does not equal 1, then I part children append, and then also deformer. And then we have the deformers themselves, which also have 2 different trees. Deformers have IDs, parts have IDs. So everything should have an ID that isn't a tree. Print part tree. Actually, I can just say print tree, and then Yeah, because they... No, because I need to know the type. I need to know the node type. Oh no, I can just check if the node is a different type to the parent node, then do not... Say nodes. And yeah, I need to iterate. This is a class. I don't one line and do a thing. I short. So then in part, I can just have an extra short thing here where I do key and self.depth. Because that is relevant. So for deformers, do a similar thing. Except instead of depth, it would be the first key point. And then the depth from that. No, deformers don't have a depth. I think. Yeah, deformers don't have a depth. Only art meshes have a depth. Artmesh has no ID. What? Because I called it name. Okay, so now we have the tree. I think. Let's actually add some let's add some lines there. Okay, that makes sense. And also, did any of the valves fail? They did not. That's good. Alright, so now, does this order have anything to do with this order? 83, 82, 81, is that represented anywhere here? Interesting, it's some of the last ones in the tree. And also the names are like totally like random. Like they have their own number, which has nothing to do with any of these numbers. In fact, we're missing some, but I guess they got created and then they never get renamed. Yeah, that 108 thing there doesn't... It's not really anything special. It's just... Oh, wait, no, that's the wrong number. That's so confusing. Okay, there's 108. Okay, so this is one idea I had is that maybe this is just the number plus 1, where 0 is nothing. That's why it's called I1 Ankh 9. So if 0 is nothing, that means that ArtMesh 29 starts referencing value 30. Okay, that is not unreasonable. ArtMesh 34 starts referencing value 35. Okay. ArtMesh 35 references value 35 also, which is weird because that means it's not it's not a clipping mask. Also, this flag is enabling things here. So that flag has something to do with those values at the end. And then we have a jump to 12, which would be 11. But then why would there be a jump though? It doesn't make a lot of sense. Unless there's another unknown in like parts or deformers or something. We don't have any unknowns in parts. And deformers, we just have this stuff at the end. That has to be something to do with the glue. Not the glue, sorry, the... Okay, let's look at these. Let's look at the rest of... I'm getting too caught up in these little details and I'm not looking at the bigger picture of the blend shapes, because we haven't done the blend shapes yet. That's all this stuff here, I think. So, Ankh 17 has how many values? Ankh 17 has 13. And what do we have there? Okay, so they are starting indices at 512, 510. And there's a bunch of counts. That sounds like it's one of the key point arrays or something like that. Possibly UNC3. Oh, that's no, that's the art mesh keys. That's not it. Is this referenced? Yes, this is referenced from, supposedly from art meshes. And they go up to like 12 or something like that. Hold on, we haven't looked at parameters yet. How do the parameters map to the key point? Okay, so parameters have a key point array count. Why do they have more than one? How can a parameter have 0 key point arrays? That doesn't make a lot of sense. And how can they have more than one? That doesn't make sense to me. What are those parameters? There's names for those. I should load these. I should load these JSONs. I really should translate this. It could be, yeah, because I know you can group parameters, but I thought the grouping was just visual, and they're still separate, logically speaking. Okay, I want to translate this. Hold on. Let's see. Let me set this up to load it, and then I'll figure out if I can get it translated. So I want the CDI 3, which would be replacing that with MOC3. Let's just see if I can add an additional load here. I guess I need like a parents by ID thing or something in here. So let's take care of that. Art, deformer, art mesh, glue. Those are the ones with names. Actually, I can just do it like this. Did I call it glues? It's just called glue. Should be called glues, but let's make it plural like everything else. And that's the other thing. There was Glues 2. Glues 2 was added right after Glue Chords. And that's the Glues 1. Oh, that's a strength. Okay, but that cannot possibly be a remap. So that's just split for no reason. I'm not gonna bother with a class for this. I'm just gonna merge everything into MOC3 and it'll make it easier. So we do data, notice data, and I care about parameters. We have parameters, parameter groups, parts. So not art meshes. So let's add a name thing to a struct. And then we can print that if it exists. Let's just add it like that. And they can also add that to short, so it'll show the names. I'm not gonna bother with parameter groups because that's not that interesting. Next time you just move the banner to the top right side doors, you can see your time like on Linux systems. Yeah, you're right. It's kind of covering it just in the wrong way, isn't it? I think I can fix that. I think that's doable. Let's see. That's in here. Oh right, that is a web thing I made. Okay, I'm just gonna cheat. Let's do this for now. Okay, I'll go with that. And thank you for the super chat. Okay, so I'm not gonna bother with parameter groups because that's not that interesting. And it isn't stored in the file anyway. Parts, we do want those. So if I do that and we print it again, I should get something nicer. Did I not do load IDs? Sure. Oh, I forgot parameters. Params. Wait, the primers don't have an ID? Hold on, what? Did I miss that? No, they should. Hold on, what? Oh, it's ID, sorry, instead of name. Yeah, rename that. And it's params map. And I messed up the name. You know what? I'm just gonna put this here in the part. Yeah, so now we have some names there. And now if I could speak Chinese, that would be great. Okay, the short is not showing it. Why is short not showing it? It is, sorry. Because the formers and art niches don't have names, those two. She is not home right now. Hold on, I think I can ask someone who might have a way of doing this. 1 second. Let's see if I can do that. Part 23 is part 23, but then part 51 is part 24, and like there's some really weird naming thing going on there. Then 8 is 20, like what? All right, let's skip this stuff and try to go to figure out the blend shape parameters, because that has to be a thing. So what about params? Why do we have so we have names for the parameters now. What are the ones that have more than one thing? Okay, so that's y1, x1, interesting. Does it make sense that something is... No, these are definitely aligned. These are definitely pointing to the right arrays. Key point array, 45, 30, and then these are like the 10. Yeah, so the mapping is definitely correct. So how come we have weird pairs? I know normally the mouth form is linked to stuff, but I guess in this case it's not. Oh, wait, what's it? Nothing. How's that? Hold on, what? I key point array 0 arrays and then none? Wait. What? What's none? Oh, because there's a -1. Okay, so there's... So there's a difference between 0 arrays and none, somehow. So this is like mouse Y. There's like a 0 arrays at 0, and then there's -1, which is different somehow. I don't know why. It's like -1 is for ankle somehow? That might just be an artifact of like... They have a weird thing going on. Unless that means that those are... blend shapes. Okay, so first of all, is there anything, parameter palette? So there's this repeat thing. What does that do? Okay, so that's new. So that basically just loops the keys, which makes sense. This might be the loop setting. And you do have to set a key on the rightmost point because of the interrelation to work. So it doesn't really change anything. It just kind of it's just It's just really a visual thing at that point. Yeah, so they just added a flag somewhere. But they didn't really... Let's validate these zeros. Form difference. Unshift keyboard key from close to the font. What is it? What is that? Changing the default form property of an object changes the behavior of all blend shapes. I mean, yeah. Okay, so what about the limit settings? The limit settings, I think you just these are the blend weight maps and values. Those you just traverse pretty much. So I guess you would apply it after. So there's no need to reference those. So instead of would that be I pair? Maybe there's only one of these in this one. This one, the only one that has a limit, is this. There's two of them. And they both affect parameter 42. Possibly. What is that? I have no idea. And the one that is affecting them is... Wait, hold on. No. There need to be two parameters here. An input and an output. So these have to be the output then. So who are the inputs? Is there a list? There has to be something with a value of like 1 and 2. Because it only has a single mapping. So it needs we need like something that was added at the same time as the blend weights. What did they expand? Nothing in parameters, interestingly enough. So where's the type? We need the 42. If it's a target, it has to be a type. But they don't have any flags. And they're definitely not all I'm still confused by this idea of multiple key points for one parameter. Like, it's almost like they are getting merged, and then you can have key points that... you know, it does kind of make sense. If you don't have to rig all the key points, if it will interpolate for you for some things, for keyforms, Is it possible it's the primary groups thing? Hold on. Because there is I think with groups and IDs. In the CDI. Parent group. We don't have any parent groups though. So I think that's not in the MOC3. No. This is so confusing. Like, do they tell you if you can have different key form? So yeah, is it possible to like not have keyforms for a parameter? But since it's multiplicative, how does that even work? Like, what's the hierarchy in that case if you don't fill all the values in? I mean, I guess it makes sense. You can still interpolate across a multidimensional space by choosing the nearest two values in... Yeah, I guess that kind of makes sense. It still works. So is that how it works? Is it because they... And the issue is, once you create a keyform for that parameter and that object at all, that has to be rigged for all of them, right? Yeah, okay, this makes... Look, I think this is what it's doing. You select the object, and then you select a parameter. Then you add the keyforms. Okay, yeah, so the list of keyforms is actually per object. That's why you can have multiple ones per parameter. Okay. That's what I was trying to figure out. So this makes sense. What's going on here is that, Damn, this is confusing. What's going on here is that these key points are rigged to different objects. So for example, if we have... Some of them are empty, some of them are unused parameters. And some of them... Like this one, for example, we have 164 and 167, right? Arrays 56 and 57. So if I search for arrays 56 and 57, they should be rigged to different objects. So whether we have 56, that deformer, right? And a few of them, yep. And, yeah, some others. With those... And 57 is rigged to some other things. Okay, so this explains the levels of indirection here. This explains why we have these extra lists and stuff. So what's going on is that the key points, the parameters map to key point arrays, which are simply lists of control points on that parameter. Then any given object is rigged to a list of those. And so we have this is the list header, key point arrays. And then this is the list contents. So I probably should rename some of these to make them less confusing. So instead of key point array, because now we have arrays of arrays and it's getting really confusing. So we call it key forms. The terminology is really weird. So what they call forms is what I'm calling keys. Maybe I should rename it to forms. Okay, what's their glossary? Key form. The point of the parameter where the shape is stored is called the key. The shape specific is called the key form. I guess I should call it forms then, because otherwise this is gonna get really confusing. So let's call it warp form. And we have rot key and rot form. Art mesh key, art mesh form. Okay, so that's a little better now. So now we have the, just to kind of go with their terrible glossary. I could call it a key form, but that's too long. So I'm just gonna call it a form. So the point in the parameter is called the key. So instead of key point array, I guess it would just be key array. So instead of key point array, well, I guess point makes sense because it's literally the points. So then I need to rename these. So P key point array, what should that be called? That should be called, there's actually, it's a list of key points array, right? So key point array, I could just be called key point arrays. Yeah, I guess list of key point arrays is still kind of valid, but L key point array should just be called key point array lists, I guess. Key point array set. That makes more sense. And then P key point arrays would be key point array ref. Okay, that looks a little less crazy. So now this is starting to make sense. So now class param, this is essentially the key point arrays as stored in the list are contiguous for a given parameter. So you always have a range of them that are essentially updated by any change in the parameter. So I'm starting to see how this would be implemented at like runtime. Okay, so this is a little cleaner now. Now about those blend shapes. So the way blend shapes works is essentially the same key point array stuff, but they are the forms are gonna be different because they are they're gonna be based on a single list of arrays. So essentially, I expect the forms to be the same, but there should be yeah, index and count here. So these are probably similar. Let's look at warp data there, see if that makes sense. Warp data. So we have group 1. And it starts at 540. And we're going all the way to 1059 or something like that. So what do we have? That is 1059. It might just be a list of key points again. Okay, so this, yeah, I think these are the blend shapes for art meshes. 510, 512, yes, probably. And so 524. What is a 524? Nothing. Oh, it's possibly just the consecutive list of art mesh forms. Yes, because that stops at 514. And then we have more, don't we? Yes, we do. Okay, so that makes sense. So 514 should be the start of an art mesh form. Yes. Okay. So that's what this is. One of these, probably the 17 one. There's more now here though. 512, is that a thing? No, hold on. 514, does that make sense? These are all consecutive. And you can see the opacity is 0 for that one. But there's a pointer to Ankh21. But those are all just zeros and ones. It looks like it's this one, but then there's a weird start index thing there. So it looks like maybe these are the blend forms. And they, and they have like a type or something like that? Yeah, because this starts in UNC 17, so this sounds like these are possibly blend forms. It can't be UNC 17. This one has to be this one. Has to be UNC 18, I think. But it's weird that we have those, like, maybe there's a type. Okay, so Artemis forms go from the new ones, the blend shape ones, start at 514 and end at 586. Okay, yeah, so this is definitely the blend forms, and it looks like there are different types. So UNC 18 is the blend shape forms. Blend shape form list or something like that. So let's try renaming some stuff here. And then we just, assuming these are those. Count blend from list. And so this is a form, and that depends on the type. Count form, and let's see what the other things are. So now, how do we know which types these are? The 1500s are probably warp. Yeah. Yes. So 1500 is warp form. And then we jump to... Okay, the top one looks like flags almost. No, 1211, that can't be flags. So maybe these are just referenced by something because there's nothing... Is it the flag? The flag, maybe? No. Okay, so one is... No, one is not... Okay, so these are unspecified type, which means something has to reference these. Without knowing what type they are, you don't know. So we have 185. And then we have a blend form list. Okay, so now these are different. These are lists, unks, and we have multiple of these references. 19, 20, and 21. So it makes sense for 19 goes up to, so let's write down these values. The blend form list for this one, 5, 14 to 586 are lists 147 through 177. And now the vertex, sorry, the rotation one, these are meshes. Sorry, these are art meshes. Warp and rotation. The rotation ones are 367 through 385. And those would be 178 through 185. And that leaves warps 1500 through 1872 plus 2, 1874. And those would be 0 through 146. So now these should be mapped in one of the other arrays. So here we have 0 through 146. So this is Ankh 19. So those are the maps. Then Ankh 20 is 147 through 176. So this is Ankh 20. And that, where does that leave the rotation ones? Here, Ankh 25. So those are the lists of blend shape. 19 is for warp, 20 is art mesh, 25 is rotation. For some reason. So this would be Ankh 19 is and this is actually an array. I guess it'd be better to call this a blend form array, and then blend form array set. Yeah, okay. So we'll call these blend from array. And then what we said it was, is 19. Unk is warp. And I guess it's a warp blend from array set. And 20 is art mesh blend form. Gets complicated. And then finally 25 is rot blend from array set. So now let's see if we can start printing these things. It's gonna get painful. Let's look at where we're printing the forms. So I print rot form, rot data. So here we do the SI rot forms. SI blend form array. Count blend form array arrays. And then for I in this plus this, oh, this would be blend from arrays to get the plurals here, right? Be plural. That's And then we print those as the same way they get printed here. Is that with forms? See if that prints. This is backwards. It's a validator to this. Make sure we have at least one. And for I in for each array. How do we call it? Blend shape. Just got blend shape. So apparently it can also do parts, art paths, and glue. So that's what the other arrays are going to be for. And they probably just are not used. Just make sure we have warp forms. That's not right. What happened here? F. Okay, that looks better. So we're looking for warp from array set, unknown, blend from array, 1+ arrays. Should probably print that in here too. Okay, that makes sense. So now we have printed in the same format. There we go. So we have 1 from array set. There's an unknown there, and then blend from array 0 plus 1 arrays. Blend from array has that stuff. My form can form stuff, and then the forms are actually those. Can do it like that. There we go. So now we have the forms printed there. Yeah, that works. Okay. Okay, I form, what's going on here? Validates. That's right, this is I, and then object equals blend from arrays I. Okay, so that still validates now. And now we do the others. So we have warp, we need to do art mesh. So the only difference here is this art mesh forms. That's the only difference. Rot forms. Rot forms. Yeah, so then we have art mesh, which is printing the art mesh forms. So in this case, I guess opacity is 0.0. Since this is a blend form, 0.0 means add 0 because everything is additive. So if you wanted to reduce the opacity, you would have a minus in there. Is my guess. So now what is UNC21? That is a flag. Why on earth is that a separate thing? I have no idea. I guess I might as well just print that reference anyway, so... Wait, I won 121. Hold on. Does that make sense? It's +1? Yeah, it's 29. That is rather strange. Another weird... off by 1 story. Because nothing has a 30. Oh, something's broken. Can't blend for array. I'll blend for... rot. Because I forgot to change that. Can't blend from array. I blend form array. There's no start there. And then this one, I'm not sure. This one from array set, maybe. No, this is rot. I don't know where that came from. This is unk. Yes. Is I on unk 21? No, that doesn't make sense because it's off by 1. So, let's see. So these warp forms have to apply to warp deformers. So something here has to reference a deformer. Like 153 should be a deformer or something like that. Because the way the deformers are linked is the deformers are linked from art meshes and other deformers, and the tree is actually kind of backwards here, but I guess at runtime it is kind of result into children, or maybe they do it like depth first. I'm not sure. But the way the data has to propagate is kind of you start at the root and then propagate the warps downwards, and so this would look through the key point arrays, and it would get the values from that and apply them to the warp forms. So the this stuff here, 542, I think has to be the it's like it's not an index. Is it just a random number? Are they linking by like arbitrary? It's like 542 too, but there's a count there, so that doesn't make sense. If this is part of a deformer, it would make sense for it to be not a blend form array. No, this is the random form. So I don't know what those numbers reference then. Okay, so what do we actually have? We have we have 71 warp blend form arrays. and they reference a number. So 0 and then 2. Why 2? And then 3. Why is it skipping 1? So if one of these things has to target a deformer, which means that there has to be a link to a deformer ID somewhere here, to a warp deformer. And that has to be linked to a key point parameter set. So there's an ONC17 link here, possibly. And that has what? Those are possibly also linked from art meshes and stuff. $510. I've seen that number before. ONC17 is 13 objects. From 510 to 537. I feel like I've seen a 508 somewhere, not the colors. Or 507. Key point array. Ah, key point arrays. Ah, key point arrays. Yes, that would make sense. It's the last key point array in the key point arrays list. So it's other key point arrays. Oh, okay. It's an index into key points because we have way more. 510. So those are key points. Start index. Okay, so ONC17 is the bland key point arrays. And those are key points. So these are the raw arrays. Blend key point array. Okay. So ONC17 is blend key point arrays. And so that is roughly going to be the same thing as key point array. Blend key point array, okay. So we just call it start count. And actually, key point array should be I key point and count. In keeping with my naming scheme. Key point and I key point. And so this is an I key point array ref. Just kind of keeping with the naming scheme. Count key points, I key points, blend key point array, I key points, count key points, sim flag is a bool 32. Validation failed. Keep an array. Okay. That's... let's count key point here. I should put validate at the end of the file so that it always prints the errors at the end. Make it easier. Okay, now validation errors, and now warp lens. Okay, so this is blend key point array. Okay, so we have the blend key point arrays. And I need to print this flag here. Not sure what that is. Oh, that's an offset then. That's not a flag. That's the neutral offset. Makes perfect sense, right? And I can make this a little bit prettier, actually. Cute. And now you get the default at 0, and I should add some brackets around that. There we go. So now the 0 is in brackets. It's the neutral position. So that means I can use the blend form arrays. And now that makes sense, because this blend keyboard array is, yes, it's duplicated, which means the parameters are going to be pointing into this. So now we have the blend form array, and I can just say, don't really need that, but we can just say, SI blend key point arrays. And that should not be plural because it's a single index. Is that right? Blend key point arrays? Yes. There we go. Now we have to keep an array for these blend form arrays. And so the way you would apply this now is you would go through the warp blend form array list, and you would just go through it. I think you don't need any index into this. You just go through this array and apply this. So this unknown has to be a warp blend shape ID somehow. Yeah, and I think this has to be an art mesh ID. That's the only thing that makes any sense. Yeah, okay. Yeah, that makes sense. So there's artmesh 31. Don't need to add that. And let's actually print the vertices too. Because I can cross-check with the VBO size that this makes sense. We go to artmesh and say vertex count. It should apply to that. 31 vertices. So we have 32 to 96. $64, exactly right. Exactly right. Perfect. So that is saying that this art mesh is being deformed by these blend forms, taking these key points with these forms. Now I wonder what the oh, that's not flag. That should be the. Wait, what's that flag actually? I wonder. Don't know what that flag is. And then we have this UNC21 thing, which is really strange. Oh, that's not a flag, that's a count. That's an UNC21 count. Because then we have the 0, yeah, it doesn't increase. Ah, okay, so there's an UNC21 count, and then it is just... that's why, okay. So that's actually I UNC21 and count UNC21. And so the validation here would be -1, and that's actually going to work if the count is 0 and I is 0, so it's fine. So it's actually a flag list. So I guess UNC21, I might as well just store it as a not a struct, but just a in 32UL. think that works fine, even if it's overloading. I think it's valid. Can I do that? Okay. Yeah, that's valid. So you can drop this one. Plus false. What? Int 32. Okay, so that's where we have all the weird ones. So there's some of them have a 0, some of them have... Yeah, okay. So for example here, there is each one has a list for some reason. And the only items in the list are 0 and 1. This could be related to the limit settings. This key point array is 512 plus 2. They're all 512 plus 2? Yeah, I think so. I think so. I think if I do unc star equals that, that one, no, 527. Five two seven 512 are the only ones that do that. Five two seven and 512. And we have these things at the end, the maps. It could be those. Oh yeah, because we have 522 and 527. I guess yeah, because there's a count for 0 too. Sorry. And 527 and 512. I think it has to do with these limitations at the end, with the maps, the blend weight maps, because there's only 2 of those. And so the only thing that's missing is mapping these to parameters. Because these stop before like 512, for example, which is one of the key point arrays. Ah, but we have some here. Blend key point arrays. So does anything reference those? Not really. So that means something else has to be pulling the parameter info. Because we're almost there. We're pretty close. We just need to map these parameters to key point arrays. And parameters were not extended when they added blend shapes. And they're all 0 and 3. So that means, no, but then that means it has to be one of these where they don't have any key points, like these. There has to be something else that's pulling from these parameters. Like maybe -1 means blend key point array, but then there has to be another unknown that we are not. Oh, this one, warp blend form. Wait, hold on, no, those are references to the warps. 527 is... Oh, interesting. So that one is actually referenced by both of those. And 512 always references 1. Okay, so there's a bunch. Let's see what these... Let's make a little list here. 514, which is 2. Oh, no, sorry, it's number 2. 512 doesn't make... that doesn't make sense. So the actual numbers are 2, 4, 6, 8. Okay. So we have 29, 29, 2. 0 has 29, 2. 34. 31, 6. 32 and 33. 8 and 10. And then also 47, 4, which repeats the same key point arrays. 48, 6, 49, 50. But no 2. Okay. And then we have again. But there's a 1 there, sorry. So those are zeros. And then there's a 1 for 8 here. Hold on. This is a little strange. And then we have 59, 4, 0, 60, 61, 62. And again, there's a 1 at 8 here. And then 147, 1 through 162. Those all 0? Yeah. No, they're not. And so we have 147 is 1. Then the others are 0. Until 157. And then we have 158 is 1. 159 is 0, and then all zeros. Okay. And so these are oh sorry, and the not that shouldn't be there. The actually when it's right is 13579. Three, 5, 7, 9. And then oh, this is 1. 1, 3, 5, 7, 9. And then it's 1, 1, 1. Okay. 1, 1, 3, 5, 7, 9. Okay, so we kind of see a pattern here where it's the same ID, always has a 1, others are a 0. So that means that effectively what is going on is that IDs through 10 are being mapped through a 0, and ID 1 is being mapped through 1, and that's an 8. No, 8 is also 1. 2, 7, and 9. There's not. Yes, it's 9. Except 32, 8. Oh, except there's an exception there. That's weird. I hate exceptions. Okay, so it doesn't actually work like that. Okay, so what are these now? These are the blend form arrays, and then they're being linked from these warp blend form array set, and so these need to target warp deformers. Do these target deformer IDs, indexes? What are warp deformers? Well, we can validate that really easy, so it's probably the former ID. And so in validate, we would say assert self mock deformers self I deformer dot type equals rotation, and then warp. Does it validate? No, it does not. We have a rot blend with I deformer 9. And that is not a warp. That did not work. Okay. So there's another level of indirection or something is going on. Unless they are just like then numbered. Nah, that doesn't make sense. There has to be another thing going on. Yeah, it doesn't work for warp or rotland. We have an I deformer 3. And 3 is warp? Wait, 3 is warp? No, 3 is rotation 2. I hope it's not literally indexing on the ID. That would be really weird. No, you can set the ID to whatever you want. That doesn't work. Okay, so then there's this other group 1 thing that I think got added at the same time. So I still don't know what Unc9 is, but that's mostly since the art mesh dependent. Yeah, that's still a really weird thing about art meshes. So again, how do parameters map to blends? Am I missing parameters? Param angle rotation. No, those are in here. And then we have this 42 in one of the in the like the limit section. Okay, so how do these map? We have like a parameter that's like 0 to 1. Okay, so let's look for a parameter that has a 0 to 1 range, because those are usually let's call it rotation 3. Not this former. So for example, let's look at a parameter that doesn't have key points but does have min-max. Like these. Okay, so these parameters have to be yeah, so none is -1. These have to be blend shape parameters. So we have 48. Starting at 106 or so. Because these are blend key point arrays, so they need to be assigned separately to parameters. And they are fairly, they should be pointing from 0 to 12. That's what this really should be. I would expect parameters to be pointing from 0 to 12. Like, we have these key points. I would expect a list of these. I'm missing something. I'm missing an association between I'm missing an association between the parameters and the blend shapes. That's like the last thing I'm missing. There's something missing here. So we have 164 warp and 77 rotation. And the former IDs that we have warp up to 146. Okay, so maybe it's just the sequential index in terms of like filtered by deformer type. That, I mean, like, which means it's an index into deformed data instead of deformer. That actually would kind of make sense. Yeah, because warp data is 164, raw data is 77. Okay, so that kind of makes sense. So that means that index there should be into the warp datas. And then I guess I should rename warp data and rot data as warp deformers and rotation deformers. So instead of type info, we just call this just say typed. Or like upcast or something like that. Just got it typed. Hmm? Okay, now it validates, so that makes sense. And so now we're left with this mystery of how this is driven from what parameters and with what. Like those 0 and 1s have to be the limit things, and then those have a pointer to like one parameter, but that's not everything. So how do we link parameters into? Is it possible it's just like is it possible it's literally just Is it possible that it is just counting up? It might just be counting up, you know. 27. No, doesn't work. I don't even know if this model is rigged for a cheek puff. Well, let me just mess with the model and find out if it does. I'm just gonna hold on. I could load myself into. Oh, no, I can't move myself. Right, that bug. Okay, fine. I should load it in here, I guess. Let's do that. Data. Streaming assets. Live2D models. Because at least this way I can test the parameters and see what looks like it is rigged and what it's not. So what is settings? You can customize model and do all kinds of stuff. But what I want to do is an expression editor. So I can create a new expression. And so these are the parameters that are open. So for example, cheek puff. Okay, cheek puff is rigged. So that one has to be valid. Where's cheek puff? Check puff. Never mind. Check puff. Okay. So check puff and check puff 1 and okay. So there are, I guess it's physics going on here. Yes, I think this one is a physics parameter. Yeah, so that's physics. But I can tell that this is moving the mouth, so this should be a blend shape. Yeah, so there's definitely some strange combinations there that don't do the right thing. But cheek puff is rigged. And so that means that this zero arrays thing has to mean something. Now what about one of the other ones? The ones that don't have zero arrays? Like this one. Oh, that also does stuff. Oh, but that could be a physics input though. But it should also be moving the thing, the head movement should not be physics though. That should be, it could be physics. Yeah, because you can see the mouth jumping, right? So that means that is rigged directly. But this one, that one might just be a physics input. So I can see that in the physics settings. So mouth press 4 should be an input, yes, and then 8 is an output. So that's what I said. There's a there's that relation between those. But the this one, angle XX, is definitely an input to stuff. Ah, there's a separate angle X. And then angle X is an input to other stuff. Okay, so I think XX is actually an input to physics only. Well, we can find out by just editing the physics file. So if I just reload the model, now angle X should not work. And it does. Oh, because I edited my production file. Not production, I edited the NAS file. So now angle should do nothing. It does, okay. So that one is not rigged, which means that that means that -1 means actually unrigged. But if it is 0, if the index is 0 and the count is 0, that means it is a blend shape parameter. As weird as that combination sounds, I think that is the only thing that makes sense right now. Okay, so now we know how many blend shapes we have. We have 13 blend shapes. Oh, and that's just Unc 17. Okay. Well, I guess I solved the mystery. It's just a blank key point arrays. It just indexes by order, as silly as that is. Which means that actually the key point set for blend parameters is fixed. You can't have a separate one for different things like you can with regular parameters. This is the only explanation I have for this right now. So now how do I assign these? I guess I have to do a city count thing in the load in the MOC3. Not happy about that, but okay. Why didn't they just have the index in there? If they just have count 0 as blend shape parameter. Why didn't they just store the count? Like the index and the count or something like that? Or I guess that wouldn't be backwards compilable, but it wouldn't be anyway. Anyway, let's just assign it here. Yeah, they could have just set the count to 0 and stored and set the I key pointer rate to that. That wouldn't make sense. I really do not like this, but it just sounds like a terrible hack they would do. Do they align up at least? I mean, yeah, it looks like they probably do. 0 to 1, 0 to 1, 0 to 1. Minus, yeah, they do. They do line up. -1, -1, 0 to 1, 0 to 1. And then the -30. Yeah, this is what they did. Oh my god, this is so hacky. This is horrible. I hate this. So now the only thing missing is actually the reference to the limiting parameter for the blend shape. So what's going on with this one? This has a reference to 42, and then limit settings for blend shape point. So how does this work? Well, we can see what this is doing and see if it works like that in VTube Studio. So it looks like the parameter is 42 is the input, and that does stuff. And I think this applies to non blend weight parameters as input. So this is mapping from 0 to 1. So we expect param 42 to be 0 to 1. And it is. It's not a blend shape param, but it is. And it has a key point of 0.5, which is something we have seen. So let's see if I can paramouth open Y and see if that does things to other blend shapes. So if I look for paramouth open Y, this one. Now, what is that one doing? It is affecting possibly a bunch of things because we saw these values get mapped in here to a lot of things. Now, the weird thing is that these are mapped differently for, like, what doesn't make sense is okay, we have both sourced from 42 and then they have these weights, and so the source value is different, fine. But then, this UNC21. Is different. So is this setting they have here per objects? Ah, there's a priority order, okay. It's so confusing. Okay, arrange parameter. What's going on there? Arrange parameter configuration for selected object. Okay. Unified parameter. So it looks like it is possibly per object, which would explain why it is mapped like this. The only one that's not consistent with this one is number 8. That has both zeros and ones. All the others are consistent. So I guess this is per object somehow. Either way, let's try number 8. So, and you should put that in here. So that's mouth press 1 is the one that is getting cancelled out by 42, which is parent mouth open Y. Mouth press 1, okay. Now it does nothing. Oh, that's a physics parameter, okay. Let's try another one then. Let's try number 2. Looks like all of these are basically controlled. Out funnel. Yeah, so that opens. And then this does nothing. Okay, so that's what's going on. Yeah, okay, so that's exactly what's going on. Alright. Solve the mystery. I really don't like some of these things, how they're designed, but let's fix the Young 21. So what we have here is actually a list of references to blend weight maps. Blend weight map. Ref. And it should be refs and sets. All these should be plural. So we have blend weight map refs, and so I should create a value type for that, just like key point array ref. Lightweight wrap refs. And instead of map, it should be called limit. bandwidth limit refs, and should just print it like that. Print the parameters here also, so we can say and do the short. And put the values. And this should be replaced to the bandwidth value. Bandwidth limit point. There we go. Blend weight limit ref. And those are referencing all those limits. And so then I need to print them here. Extract intent. Okay, now, okay, 2 indented here, 41, 42, it's just 4 here. Okay, that works. We have the blend weight limits. So essentially, the way you process this is you just go through this array, and I think you just apply all the blend forms with all the limits and everything, and then that's it. I think that's how you process this. How many unknowns left? Not that many, actually. We have UNC24 and UNC26, which are not used. So those are the features we just don't know about. And we have UNC9, which is kind of a mystery. That weird art mesh thing that doesn't make any sense. I think there has to be oh wait, What is this blend key point arrays? Is that a blend key point arrays? I'm not sure if that makes sense. 10? No, I don't think so, because look, oh, I think I know what this is. This is Unc 9 again. Because we jumped from 3 to 10. Right? And so what happened to all the other ones? But then this has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then it jumps to 12. Okay, so that one is not... Yeah, okay. So this Unc 9... Okay, this is starting to make a little bit of sense. Because we still didn't figure out clipping, and I think this has to do with clipping. So there's no I1 anymore. Wait, hold on, what? I thought there was a jump there. Oh, huh? Oh no, because there's two. I can't use the same name. Oh, and then Unc Flag 3 here is also duplicated. Oh, that's bad. That's bad? Can't do that. Oh, that's confusing. I have to make sure I never do that anywhere else. Okay, so still those flag 4 and... wait, so then flag 3 was getting overwritten, which is probably why that was counting wrong. 0, 1, okay, look, 0, 1, 1, 1, 2, 3, 7, 10. Oh, that's why I was so confused! Because I was overwriting that. Okay, so that's just a count. This is a pointer into Unc 9, and it's probably just a list of... It's probably just a list of, a simple list of clipping masks. And then I don't know what this one is. Now it makes sense. Okay, so looking at this again, now that it actually makes sense. Yeah, so 27, 28 is clipped to 30. And 33 is clipped to 35. And so is 34. And 47 has some references to like something else. So there's another list of things involved in art meshes. But then 59 is clipped to 53, 54, until 58. Oh, that makes perfect sense. Okay, let's fix that. So 9 here is art mesh refs. And give it a short description for that one. So then Unc 9 here is an art mesh ref. And so this is test mesh ref and count art mesh refs. I guess in this case, instead of refs, you should call it art mesh clip refs. So it's obvious that it's a clip. Art mesh clip ref. Art mesh clip is fine then. And unless they reuse that later for something else, but let's hope not. So then clips is gonna look like this again. Clips. Let's do something better like that. There we go, no clips until we find one. And now it shows you the clips. Okay, good. I was getting very confused about the clips. So now what's going on with the other stuff? Art mesh forms. So I have no idea what this order thing is. It could be a reference to the multiply color for some reason, which is weird. Or it could be a different thing. And then this one here, reference to 11. So this is counting up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Counts up to 12. Do we have anything that is a 12? We do not. Unless it is the... no. So this is clipping from 53 through 61 and 58. So it's not the ones that become clips. It might be the number of art mesh blend some things. Because we have 15 of those. The first one is 31. We have 18. So it's not that. The first one is number 18. It's doing something. So that's in group 3. That was added almost the last thing we have to work out. In 5.0, let's look at the features for 5.0 again, because they're almost there. So the new 5.0 features. Blend shape and motion sync. Is motion sync a thing that I need to care about? No. Oh, but blend shapes, though. Blend shapes in principle can there's the glue stuff. Yeah, so these, hold on. So first of all, these are probably, Getting new parts, art mesh, warp deformer, return deformer, and glue. So we are missing parts and glue. And then these are missing like a, we would be missing like glue. Like what, I wonder what blend positions this uses. Maybe it's just vertices at that point. Let's declare those, I guess. I guess we don't really have to. When we run into those, we'll figure it out, or we can just guess. Those are guessable. Pretty sure figuring out how those work is guessable, and that's it. We know all the objects. We don't know all the flags and things like that. Now the only thing that's I'm curious about is that what's going on with. There's like a flag, and then there's a count based on the count. So that is supposedly new in 5, which means it's one of these. It's either blend shape, but it's not that, or motion sync. What's motion sync? No, I don't think we care about that. Do we? I guess there's a model, so there is some kind of motion sync thing. But this is just going to parameters, so that doesn't make any sense. It has something to do with art meshes. If it's something that was added in 5.0, I mean, it could be blend mode. When does when was this released? That was January 2026. So that this model is way older than that, so it cannot be that. Let's look at the release notes again. Okay, so what's going on in 5.2? Yeah, so they expanded the blend, off-screen rendering. That was late 2025, but like these models are much older than that, so it cannot be that. Unless they were already editing the format by then. But I don't think so. So then what's going on with the, and besides, it wouldn't be used then in this model. So, there's something with the 13. Yeah, it's going up to 13. There's something with 13 objects. And we don't really have a 13 of anything. It's a mystery. Could it have something to do with glue? So the art meshes that have this set are, let's make some notes. $18. 47, 48, 56. And then 6311 for 12. And that's it. And they don't really line up with anything. They're not a subset of parts. it's not correlated with anything else other than it being Atlas 1, which it's not. Oh, actually, yes, it is. Those are on Atlas 1. No, the first few are in Atlas 1. And then nothing. It is a mystery! It's a mystery! Nothing... That's the one thing that doesn't make any sense yet. Well, that's, at least rename these things to, Unc enable bool 32 and I Unc start and count Unc. So at least we know it's something like that. So we know it's a flag, and then there's a count in there. So it does have anything to do with the blend shapes, right? Does it? Nexus 31 doesn't make any sense. Is there anything else in the file that I like? Is there a reference anywhere else? Could it be physics related? No, because this only works in parameters. And the CDI has groups and stuff. No art mesh stuff. Huh. Let me just go back to the inspector, see if there's anything I missed. Art meshes, okay. So another clipping, there has to be a invert clipping flag, but that can just be any of the random flags that we have. It's quite likely this model doesn't use it, so could be any of these flags. Now, the opacity and the depth are part of the forms, so that should not be an issue, and the colors too. We have the blend mode and the alpha blend, and those are for the current version. If we go back a little bit, it's just a blend mode and culling. It should be normal, additive, multiply. So there should be one of these, possibly the type is the blend mode. I'm quite stumped. I don't see anything that is a list here that would make sense as a list. And, like, there's nothing. Unless I messed up that group and it wasn't our meshes? They do line up. See the EA3, C0, 163, 180. But interestingly, they are okay. It is possible this is just completely wrong because is there anything with about the same number as the number of art meshes? Because this is guesswork. And there are a lot of zeros at the end. And if there's something similar, I might have just gotten that part of the object completely wrong. We have 169. Oh, it could be pair. Oh no, is this the blend shapes? This is the blend shapes, isn't it? These are params, not art meshes. I messed up this is what I was missing in the params. This is what I was missing in the params. This is the stupid counter. Oh, this is what I was missing. I got the wrong object. This is a param extension. Well, suddenly it makes a lot more sense now. Because the number of params, the number of art meshes is close, so the array length is the same, and the end was not obvious. This is a params extension. And now you're gonna see how it's gonna make perfect sense. See? It's the blend shape. It's the blend shape marker, and then the key point array, and it actually has to start an account, which means you can have more than one. Okay, well that. Fine. Okay, so get rid of all this nonsense. What happened there? And suddenly it makes sense. Why did I not realize that this 13 there is... It's 13. It should have been obvious. The number goes up to 12. We have 13 blind... I wonder what that type is there, what I have untyped there. Parameter palette. It could be the repeat setting. And to say possibly repeat flag, because that would make sense. And the 3 is kind of mysterious. I guess it could be a group or something, but it doesn't make sense that they're all in the same group. And there is a... Parent... Oh, parent group 2, 4... No, there's a bunch. Let me look at imhex again just to make sure I didn't miss anything. Yeah, that says 3 everywhere. Could be related to the interpolation. But I think this is an editing level feature, though. Not something... I think this is baked. I want to say. Yeah, it increases the modifying. Okay, so it's this is baked. Yeah, I don't know what that is. Mystery number 3. Okay, what else are we missing? We might be able to just make a few guesses now. So part has some flags we don't know about. Is that grouped? Did I get that right? I think that's just a guess because I've never seen that, but it does kind of make sense. The 3 flags are probably compatibility things. Group, okay, the image and off-screen drawing. Well, we know off-screen drawing is off. I don't think they're all grouped. Yeah, we don't know what those are. It might. Oh no, wait. Those might just be the like visibility settings. It's probably like the visible. It's like it might be like a show hide. It's probably show hide. It's probably something silly like show hide and expand or something like that. And then the former should also have that. And art mesh should also have that. Yeah, those are always on, the Unc Flag 1, Unc Flag 2. Let's change the types of those. We still have an unknown count on the warps. What are those? Oh yeah, we're missing one thing. There's one more mystery here. 540 and 542. Okay, what is 540? There's a warp form. Are these warp forms taken? They are. Could it be the colors? They're looking for like 539 or 538. Okay, so it's not the colors. Okay, so it doesn't make sense as a VBO. It was added with the multiply colors. Go back to the update history. Not update history, the target version. Art mesh and warp deformer shapes. Those are suspiciously... Are they? Group 1 in art mesh. That is still weirdly unknown. Was added in 3.0 together with glue, so that does not work. In 4.2, they added this, but this is before, so it's not bad. Okay. The deformers were also added in 4.2. But these only got the multiply color. Is it possible that I'm also messing up those arrays? Hold on, something to X to count. This could be another I got the wrong array thing. 164 warp deformers. Oh, art meshes. Oh, are these art mesh? These could be parameters, art meshes. Oh, this could be anything. I might have just guessed this very wrong. Okay, I'm gonna take a very quick break. I'll be right back, but I think I might have just messed this up. I'm back. Okay, we're almost done. Just... Oh, look. I can tell already that this is wrong. That's silly. Okay, I'm off by 2, which means this is not... This is params. It's not warp datas. It's a params extension. So there is one that is warp deformers, I think. The multiply color is right, because that's the same as rot. But these are not. These are a param extension. So going back to params. Then it would be like that. And I bet certainly this makes some sense. So what could param have that has that kind of values in it. So, okay, look here. See, 13. Okay, that's the number of... That's a key point array thing. That's the number of key points. It's like the core number of key points. Like I said, it's probably a key point array. So, for example, is there a 540? It's not in the arrays. Ah, it's right after the blend key points. So it's some kind of extra key point array stuff. Actually, it's actually key points. It's a set of key points. It's an extra set of key points is what it is. So it's basically a like core key points list, really, is what it is. It's basically a default set of key points. There we go. So now there's the key point array there, and it's just an extra array. I don't know what it does, but it's probably just like informational or used for, I don't know. Okay, let's add a validation here. So the ones that are not assigned, it's basically the largest key point set that it has. Like the overall, the union of the key points. Yeah, that makes sense. And so then we just have this flag, which we don't know about. Whatever the type is, which you also don't know about. And this 0 thing, which is also unknown. So the kind of weird thing is that there's this blend shape thing set as like art mission warp deformer shapes. And I'm not sure what this means. Because then they added the whole blend shape thing afterwards. Let me check the 4.2 release notes. Just to see if any of that makes sense. It says blend shape functionality has been added. Okay, let's go to 4.2. What is in 4.2? Blend shape. Okay, so if you can't edit keyforms, what? If you can't edit keyforms, what's going on? What is this blend shapes in? Supposedly it has the limit settings. So it supposedly has this whole thing already. But then they said they added it in 5.0. Or maybe they just changed how it works. Oh, no, I think I get what happened. Ah, I get it. Okay, so what happened is this is wrong. That was added then. All this blend shape stuff was added then, including the limits, and then the so those are the colors. So multiply color was added then, so then it's like this then. 5.0 is when they added the these three things, which is the blend shape. This is not set right. They do have this for art mission warp deformer. They added it for parts rotation and glue. And then motion sync is whatever. So that's actually what is 5.0 plus. This is all 4.2 plus. Okay, I'll go sleep. Okay, what else is unknown? Okay, unknown 0, glue, these are the ones we don't know, which, should be the... Given what the order they have it, it should be, parts, rotation, and glue. It's actually created like this. Glue, blend, form, array, sets. I'm just gonna throw those in here as guesses. I didn't even print the global floats. What was those, actually? Hey! I'm almost done. Like, I'm pretty much done. I figured out almost the entire file.
Seriously?
Yeah.
Did you eat?
Not really. Oh, thank you so much. It looks amazing.
It says amazing. It's the best chicken I've ever had.
Thank you. Mmm.
Hot.
Oh, I see. It's so good.
Well, it's takeout.
Master like that. Hmm.
Show me your reverse engineer file format.
What's this?
Yeah? Chinese?
Yeah, because this is my model.
Do you have the permission to add to look at this model? It's just the file format is fine, I guess.
Yeah, I'm basically looking at the file format, so...
You're not open source this through the stream,
No,
right?
I don't think so.
Thank you for super chat. Thank you, arigato.
Wait, what assertion is failing here? A param assertion?
Eat my food. I saved
will,
it for
I will.
you. It's too good. If you waste it and you go back tomorrow, I'll bite you.
Okay. Uncle Zero. Oh, because Uncle Zero is an U32. Wait. Oh, there's 2 of those. Uncle Zero 2. That's why.
Hi, fish. The translation completed? What translation? You've been secretly translating things?
I think this is from Mario, and I didn't copy it. Hold on. Let me put that in.
Nani?
I got the.
You got what?
I got the translated file from Mario, so.
slow it down.
Uh,
See you tomorrow.
I'm almost done.
You're almost in 3 more hours.
No. Seriously, I'm just like.
No. It will nobody but you.
What is this? Downloads? Where did it go?
I'm careful.
Mystery file is not anywhere. Mystery file is not anywhere. It's like Finder, and then Finder doesn't find anything. So much for Finder. Buggy! Where'd this go? Disappeared. This is Buggy. Okay, now it worked. Strange. Ah, right, that problem again. One second. Okay, so now we have the names in English. Makes it a little easier. Just to make sure those art mesh, the first art mesh extensions are where they're supposed to be. These are right before glues. And this one is definitely right. So the only thing that is an interesting question here is whether the these maps here are correct or not. Because we have that strange indirection table for art meshes. That could be off somehow, but it doesn't look wrong because it kind of is backwards, and these are all pretty much in roughly the right order. So yeah, I don't know what those are. Could be a draw order thing. Yeah, actually, that one makes sense that it's like a current draw order because the top of the tree is drawn last. Yeah, what happens if I just print the order? It might actually make sense. In art mesh, it wouldn't be the other. It would be the It would yeah, okay. I think those then aren't an extension. It's like a draw order list. If I do Unc order, and these are just if I open order.txt and look at the part graph and the part tree, what we have is artmesh 0. Okay, so this would be backwards. And what we have is 78, 79, which are likely the 400 ones. We have 138. Okay, so 138 is the weird depth one. And that is actually near the top, so that is kind of makes sense. It's okay. Yeah, that's probably a draw order list. And so it probably gets updated as you change the depth. So here's the part tree, artmesh 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then you get 85. 84, and then 10, 11. Because they go like that, right? 85, 84, 10, 11. So 11, 10, 84, 85. 11, 10, 84, 85. 11, 10, 84, 85. Ah, because these just have a parent ID, but they don't actually hold the order in the tree. That's why. There's no sort order for art meshes within a tree level. Ah, so then these are actually up there. That's why. So yeah, it really is the draw order, and it is a separate object. So it's not art mesh. It's a class draw order That makes sense. Art mesh orders. Art mesh, let's just go to draw order. So then we can just drop this from here. Which explains why we had the separate count. So then reconstructing the tree is actually going to be a little bit weird from this. It's doable, but it's a little weird because we would have to basically find the subsets of the tree that are in each part. You basically need to like index into it and then sort by the index into the, yeah, okay, it's doable. So then we can rename it. Instead, this is draw orders. But that would still have to be updated later when the depths change. Like I guess it's this is the order within the same depth. And then you have to like filter by them. And then we can drop this. And it validates. Yes, now we have the draw order there. And that's -1 there. Who knows what that is? So interestingly, this is the tree order. It's because this overrides that unless it has the flag set. So then if I want to resolve the tree, essentially what I would do is do like a resolution pass. I would say something like it doesn't matter. This is just information. We don't need to sort the tree. I should go to sleep. So let's do let's add a validation to that. So validate self cert self that zeros. One, and I'm just going to do that for the rest of everything. So assert the flags are flags, onto type and I don't know what that is. But it's always 4 or 6. We have those, and then unc type is 3, unc flag is true. That and glue is always true, maybe. Yeah, that's always 1. Let's go with unc flag. I think that's it. We have very few unknowns left. Very few unknowns left. Because the art mesh, we got rid of that weird stuff that didn't make sense, and so now we're just left with the type is probably the blend mode. That makes sense. It's the only thing that makes sense. So I'm just gonna call that blend mode. Let's see what 4.2 says about blend modes. Normal additive multiply. I'm guessing 4 is normal, 5 is additive, and 6 is multiply. Because additive is probably not used in this model, and multiply probably is. Because multiply is used for like shadows and stuff like that. We can probably check with the blend with the customization stuff. If I do customize model and if I customize the multiply screen color, so for example, this art mesh. Art mesh, 25. Which is where? Here. See, that's a shadow. That is a shadow. So then, yeah, that has to be a blend mode, and it probably means that the old numbers were like weirder blend modes or legacy stuff. So that has to be a blend mode. So you can just do the enum thing again. Art mesh. Blend mode. Normal equals 4. I wonder why that's an 8. That's an 8. That's so weird that it's an 8. It's the only thing in the entire file that is in a single byte instead of a word. Ah, there's a 0 blend mode somewhere? Did I mess something up? Oh, it's because the default value is 0 and then it'll fail. Because of the way I set default values for everything. And I think I had a fix for that. Because the way I'm doing the initialization in the Struct here. Yeah. It allows a default, so I can fix that as that. Yes. There we go. Another thing mostly sorted out. And then we don't need to validate that anymore. And then just some silly flags is all we have. Zero is an optional index, has something to do with draw orders. That is it. That is everything. Oh, and I just realized, was that? No, that is right. That is right. Yeah. That's it. That's pretty much the entire file figured out with just a single sample model and not even testing anything yet. Just by looking at everything. I mean, there's things I don't know, you know, like exactly how the meshes are ordered and, you know, how the exact math to play everything back, but that's pretty cool. I think that's pretty cool. Besides curiosity, we're planning to do something with this. Read the FAQ. Read the FAQ in the read description. It's all explained there. Okay. I'm gonna take a nice like show off screenshot of everything. Not that. I think that's it. I'm just gonna post this on Twitter later. Like after ending the stream. Alright, any questions? Anything else? Before I head out? Thank you everyone for the super chat. Thank you, Jody. Sorry, I was so concentrated. Say silent for us. Thank you. Thank you so much. Alright, so I guess the next stream is gonna start. It's gonna be about writing at least a test render for this. I'm not actually sure. I mean, one thing I could do is first thing I have to do is be able to write out files, which is not hard. So I'll write the code to write out the models again, so I can modify some things and test them in VTube Studio and see what actually happens. But I'm pretty confident about almost everything except some of the flags. So that should not be a lot of testing. And then we have to start doing some kind of testing and rendering, and I'm torn between starting to do something in Python just as a demo, or jumping straight into like writing a Rust implementation of this and trying to get some kind of production renderer going. So yeah. Has anybody seen some of this in the future still planned? Yeah, I think we need to figure out a time to do that. I'm so sorry. Alright. Well, that was 2 streams. And I think we worked out pretty much the entire file. So yeah, that's that. I must have forgotten some flag that is not marked as unknown. I mean, the header thing is kind of unknown, but it seems useless. It might just be like a hidden thing or locked thing or something like that. Wouldn't be surprised if it's literally just like a hide thing. But yeah, I think that really is it. Oh, here, this flag one. Okay, so I need to be honest and add an unk in those. I need to be honest and add an unk in these. Okay, that is everything now for you. Okay, there we go. When is the next stream? Next stream is probably sometime next week, Wednesday or something like that. We'll see. Or Thursday. Haven't decided yet, so we'll see about that. Alright, everyone, thank you all for coming. I'll see you next time. Bye bye, bye bye. See you next time.